Once again, welcome to this CAT for MBA channel by Unacademy. And as you know that this is the place for all your CAT 2020 preparation, not only CAT, but then we are going to take care of all the entrance exams related to MBA, that is SNAP, CET, CMAT and others. My name is Ronak Shah, and in this session, we are going to revise the complete number system. Yes, so this is going to be a 3-year-long marathon session, and the objective is to make sure that we are through with the number system concept. So if you look at the weightage of number system questions in CAT exam, so that has varied over a period of time. Sometimes there have been about 20% questions. So as you know that in CAT section you have 34 questions from quant, so about 20%, that is 7 questions have been from number system. Sometimes there have been fewer questions. In fact, if you look at last year's CAT paper pattern, there were just 1 or 2 direct questions based on number system, but still this area is very important because all the other concepts rely or they are dependent on your understanding to this particular concept, right? And that's why it's a must for us to be very well versed with all the concepts of number system, right? So as you understand, this is going to be a marathon session on number system. Okay, so let me quickly brief you about myself in case if you are new to this channel, if you are attending my session for the first time, then this is a brief about myself. So I am an MBA and I've also completed my engineering. I have more than 12 years of training experience, and in this last 12 years I have trained more than 10,000 students for CAT and other MBA entrance exams. Not only I have trained them for quant and LRDI concepts, which I'm good at, I have also mentored them for the queries related to admissions and college selection process and many other areas, right? So I have personally appeared for CAT 5 times and I've scored more than 99 percentile twice. And we have the best of the educators on this channel. So we have team of the educators for various subjects. So definitely you can attend our daily live sessions. Okay, so let me quickly brief you about this session. We are going to discuss the very first concept of number system, that is number line and modulus. In fact, we are going to revise that. We'll also discuss HCF, LCM, divisibility in detail. So even if you haven't attended my previous sessions on number system, this session will again be fairly sufficient for you to revise all these concepts or to understand all these concepts, because we'll not only be solving questions, but we'll also look at the basics of each of this concept. Then we'll discuss concept of prime factorization, and we'll also understand how to quickly find out number of factors of any composite number. Then we'll discuss remainder related concepts and theorems and cyclicity. So cyclicity, as you know, it is used to find out last digit of any number. Then we'll also discuss concepts related to finding last 2 digits of the number, right? And then the last part, factorial, binomial and algebraic expression related questions. So this is what we are going to discuss in next 3 years time. So I'm sure all of you are ready with your water bottle, and if you want you can keep something for munching also. So that's the beauty of this online education, that you can be at your ease and you can enjoy the learning process, right? So yeah, hi Akash, Nicole, Varshini, good afternoon to all of you. Are you all geared up for next 3 hours? Guys, show me a thumbs up quickly. Right, so I'm sure all of you have kept your water bottles. See, I have kept my ready. So make sure if you want, you can mix something like Tang or Glucon-D in that will be required. Okay, but yes, I'll try to make it as comfortable as possible and as easygoing as possible. So we'll proceed in a step-by-step manner. So I'm sure you will understand all the concepts thoroughly. Okay, once again, so in case if you are not aware, if you have randomly jumped to this channel, then let me tell you, this is Unacademy CAT4MBA channel on YouTube. So you can quickly subscribe to this channel if you haven't subscribed, and do not forget to press the bell icon so that you can get updates about our daily live sessions. So every day we conduct about 8 to 10 hours of sessions on this channel, and yeah, you can also subscribe to our CAT4MBA Telegram channel. Right, okay, now quickly tell you about our subscription plan. So like you are attending session over here on YouTube, we also conduct the sessions on Unacademy app or Unacademy platform, you can say. So you can quickly download the app and you can take a subscription, and you can enjoy many more benefits, like you will get access to mock test series and leaderboard, and you can interact with the faculty on much more personal level. There will be small batch sizes, and you will have particular exam specific preparation. So there are many educators who are running their courses on that, and once you have taken the subscription, you can access any of that course. You can watch it n number of times, right? So what you need to do is, once you have downloaded the app, you need to select your goal as CAT, and you can check the subscription plans. You will find this plans over there. I'll suggest to go for 12 months plan if you are going to appear for CAT this year, or 24 months plan if you are going to appear for CAT next year, because you will require to get more time. Even after CAT exam, you will require to prepare for other entrance exam like SNAP, CET, CMAT, NMAT and all, right? So let me quickly tell you something about the offer. So you can use this referral code, my referral code, that is SHAH10, and you can get 10% special discount. So please enjoy this benefit. Now guys, let's go ahead. So starting with number system. So first thing that we need to understand is classification of classification of numbers, which we learned during school, right? So let's quickly revise that. So whatever real number you take, in fact, let's go a level above. So whatever number I take in the world, it can be classified in two categories: real number and imaginary number. Imaginary number are not part of our syllabus as far as CAT exam and other MBA entrance exams are concerned. So all the questions are based on real number only. So we need to understand this real number in detail. But just for your information, let's quickly understand what are these imaginary numbers and real number. So number which can be located on number line is called real number. So I'm sure you understand what is a number line, right? So this is the number line where we put 0, 1, 2, 3 and so on and so forth. Normally we write it this way. Okay, but these are not the only numbers on the number line. There are infinite numbers on the number line. In fact, between 0 and 1 also there are infinite numbers. Between 1 and 2 also there are infinite numbers and so on and so forth. So whatever number you can put on number line is called a real number. So that means imaginary numbers are those numbers which cannot be located on number line. They do not exist on number line. So what are the imaginary numbers? Right, so number like this one, root of -4. So root of -4 is nothing but root of 4 into root of -1. Now this root of -1 is not defined in mathematics. Root of any negative number is not defined. So we are taking that as iota. So this root of 4 is 2. So this number became 2i, and this is nothing but an imaginary number. Fortunately, as I mentioned, we don't need to study imaginary numbers. We just need to deal with real numbers, right? Okay, so rational numbers. So real numbers can further be classified as rational and irrational numbers. So quickly, all those numbers which are of the form P by Q form, or all those numbers which can be represented in P by Q form, are called rational numbers, and irrational numbers, they cannot be represented in P by Q form. So guys, if I take number like 5, or if I take 1.4 or some other number, see 5 can be written as 5 by 1, or 1.4 can be written as 14 by 10. So all of these are nothing but rational number, because you can represent them in P by Q form. So what are the irrational numbers? So guys, if you take any number with root sign, say root 2, root 3 or cube root of 4, all of these are nothing but irrational number. In fact, they are non-terminating, non-recurring decimal. Now what does it mean by non-terminating, non-recurring decimal? So if I try to find out the value of root, which some mathematicians have found out, so it will be 1.4118675174, something like this. It will keep going on. So there will be no pattern over here. That means non-recurring, and they do not terminate. It will go on till infinity. So all these root wale numbers are called irrational numbers. Guys, are you all clear up to this point? Yes? Okay, great. So then rational numbers, as we have understood, all the numbers which can be represented in P by Q form are rational number. Now, when I represent a number in the P by Q form, and if this Q, that is denominator, if the denominator is 1, so we call that type of number as integers, right? And all other numbers will be fractions. So if I write 3 by 4, it's a fraction. But if I write 5 by 1, 5 by 1 is nothing but 5. So it's an integer. Integer can be negative or it can be positive. In fact, 0 and positive integers are called whole numbers, and negative integers, so -1, -2, -3 and so on and so forth. So I'm sure you are pretty clear about this number classification, right? Okay, further, these fractions are of 3 types, guys. Quickly: proper fraction, improper fraction, mixed fraction. So proper fraction, your numerator is less than denominator, example 3 by 4. Improper fraction, numerator greater than denominator, example 5 by 2, or you can say 7 by 4. All of these are nothing but improper fraction. The values, if you convert them to decimal, the value will be 1 point something or 2 point something or something like that, right? This improper fraction value will always be 0 point something when you convert them to decimal, right? Okay, now what is this 7 by 4? So if I can, when I divide 7 by 4, 7 divided by 4, so I can say 4 ones are 4 and this remainder is 3. So I can write this 7 by 4 as quotient and remainder divide by divisor, that is 1 and 3 by 4. You can also interpret that as 1 plus 3 by 4, right? So this form of fraction is called mixed fraction. We call it mixed fraction. So we have seen three types of fraction: proper, improper, and mixed. Yes, are you all clear with this? This is just basics of number system, right? So let's quickly go ahead and let's understand the concept of modulus. Right, so we have been understanding modulus this way, that mode of -5 is 5, or mode of 3 is 3, and so on and so forth. So whatever number we put inside modulus, when we just solve it, it should become positive. This is how we have understood. So that's not the correct understanding. In fact, that's very limited understanding. This is not incorrect, of course, but the understanding is very limited. So let's understand what is modulus. So guys, please understand, mode of x minus a represents distance of x from a on the number line, right? So modulus is a function which indicates distance of one number from another number on the number line, correct? Okay, so here, for example, if I take number like 5 minus 2, that means on number line I need to find out distance of 5 from 2. So can I say 5 is 3 units away from 2? So that's why this result should be 3. In fact, if I say mode of 2 minus 5, now can I say 2 is also 3 units away from 5? So that's why this result is also 3. Since you know distance is a non-negative quantity, and that's why we get 0 or positive result outside the modulus. So for example, if I say mode of -5, so how will we interpret that? So mode of -5 can be interpreted as mode of -5 minus 0. That means we need to find out distance of -5 from 0. So as you understand, -5 is located at 5 unit distance from 0, and that's why this result is written as 5. Correct, everyone? Are you all with me? Fine, great. Okay, so this is modulus. Okay, now let's take couple of questions. In fact, when we'll discuss algebra, you will require to use this understanding over there. Okay, so guys, if I ask you mode of x minus 2 is equal to 4, what are the possible values of x? So if you just figure out, you can make out, okay, it should be 6 because mode of 6 minus 2 is 4, or it can also be -2 because mode of -2 will be mode of -4, which will again be 4. Correct? So these are the possible values. So how can we understand this one? Using the concept of number line. So let me show you over here. So this is 0 and this number 2. So let me first put number 2. Let me put number 6 and number -2. Now mode of x minus 2 indicates distance of x from 2. So which are those numbers which are located at 4 unit distance from 2? Guys, which are those numbers? Can I say those numbers are 6? So this 6 is located at a distance of 4 units from 2. Same way, this -2 is also located at a distance of 4 units from 2, right? So that's why we say it can be 6 or it can be -2. So I hope you all are very clear now with this concept of number line. Yes? Okay, in fact modulus rather. Right guys? Fine. So let's quickly understand the concept of greatest integer value and least integer value. You know, sometimes the questions have been asked based on this concept, and it's very interesting. So greatest integer value of any number, normally represented as g of x, it is also called greatest integer function, and same with least integer value is also called least integer function. So greatest integer value g of x means greatest integer smaller than or equal to the x. Ultimately this should get us the integer value. So for example, if I take g of 3.2, okay, so if this 3.2 is an integer, you will straight away write down that as 3.2, but 3.2 is not an integer. So identify the location of 3.2 on the number line. So here is that 3.2, right? Now as per the definition, we need to find out greatest integer smaller than or equal to x. Of course this x or the number itself is not an integer, so we'll have to find out smaller integer than 3.2. So which integers are less than 3.2? It's 3, 2, 1, 0 and so on and so forth. Among this, which is the greatest? Of course it's 3. So in simple words, what I'm trying to tell you is greatest integer value of any number will be the number itself if that number is integer. So for example, greatest integer value of 4 is 4, but greatest integer value of 3.2, now 3.2 is not an integer. So what you need to do is you need to look at the first integer towards the left of that number. As simple as that. check for the first integer towards the left of the given number. So 3.2 के left में पहला integer कौन सा आएगा? 3 आएगा. So greatest integer value of 3.2 is 3. Let's take few more examples. What is the greatest integer value of 0.99? Now 0.99 is not an integer, otherwise we would have written that directly over here as a value, but 0.99 will be somewhere over here just before 1. So now which is the first integer towards the left of the 0.99? So of course it's 0. So greatest integer value of 0.99 is 0. Same way if I ask you what is the greatest integer value of minus 3.1? Now where is minus 3.1? Of course it's over here. So which is the first integer towards the left of minus 3.1? It's minus 4. So greatest integer value will be minus 4, right? Same way, least integer value is exactly opposite. We need to find out smallest integer greater than or equal to the x. So for example, if I ask you to find out least integer value of 4, of course it will be 4 because it's an integer, so it will be as it is, like in the case of greatest integer also. But if I ask you to find out value least integer value of 4.9, okay, so where is 4.9? It's somewhere over here. So now you will look at the first integer towards the right of that integer. In greatest integer, we look at the left side if the number is not an integer. In the least integer, we look at the right hand side. Okay, so which is the first integer on the right hand side of 4.9? Of course, it's 5. So least integer value of 4.9 is 5. Same way, what is the least integer value of minus 3.6? So where is minus 3.6? It should be somewhere over here. So which is the first integer towards the right of this? Of course, it's minus 3. Correct? So are you all clear with this concept, guys? Show me a thumbs up quickly. Yep. Who all have joined? Quickly show me a thumbs up so that I can make out that, okay, the students are present. Yep. Fine, and I'm sure since you have understood that earlier, so this will definitely conquer your understanding. Okay, fine, guys. So let's go ahead, and just before I go ahead, so quickly tell you about my special classes. So if you have downloaded this Unacademy app, you can search me by my name, which is Ronak Kumar Shah. And once you have searched by this name, if you do not find my name, then click on that all educators. So once you click on all educators, you will see my name over there, right? And then you can just follow me so that you can attend all my special classes. So tomorrow at the same time, that is 2 to 5 p.m, I'm going to conduct a marathon session on this Unacademy platform, and it's going to be about permutation, combination and probability. So do not miss that session tomorrow. Make sure that you have downloaded the app, you have followed me, and if you have attended my session over there as well, then do not forget to rate me. Okay, yes, so tomorrow we are going to conduct this marathon session, everyone, and it's free of cost. You don't need to take any subscription for that. So let's solve few questions related to this modulus and greatest integer value and all. So what is modulus of 3.2? Of course it's 3.2. guys, please keep solve quickly and tell me the answer of this question number 1 and question number 2. I'll be solving it over here. You should beat me, okay, because I'm writing all the steps and you should try to do it in your mind. Right, so modulus of 3.2, of course it's 3.2. Then modulus of minus 3.2, again it's 3.2. Then greatest integer value of 3.2. So we'll look at the first integer towards left of that, so it will be 3. And greatest integer value of minus 3.2. So again we'll look at the first integer towards left of that, so it will come out to be minus 4. So if I just solve this thing, so it will come out to be positive 5.4. Yes or no? Everyone, 3.2 plus 3.2, 6.4 plus 3, 9.4, minus 4, it's 5.4. Yeah, so this is the answer for first one. What about second one? Robin, that's incorrect. It should be 5.4. Right. Okay, so once again, greatest integer value of minus 4.8. What is greatest integer value of minus 4.8? Of course, look at the left side integer, so minus 5. Into least integer value of 3.2, so look at the right hand side first integer, it's 4, into greatest integer value of 3.2, left hand side first integer 3, and least integer value of minus 4.8, so right hand side first integer, it will come out to be minus 4. Just multiply them. Of course this minus will get cancelled off, so it will be 5 4s are 20, 3s are 60, 4s are 240. This is the answer. If you want to crack CAT, if you want to score 99 plus percentile in quant section like I did, you need to beat me. As simple as that, guys. So you need to think really fast. Make sure that your calculations are really good. Okay, fine. Okay, so let's look at third question. Now here first we need to find out greatest integer value of minus 3.2, which will be minus 4, and then modulus of minus 4. So it's going to be 4. So this is the first part, plus modulus of minus 3.2, so it will be 3.2, and then greatest integer value of 3.2, it's going to be 3. So what is 4 plus 3? It's going to be 7. So this is the answer for this third question. And same way, I'm sure you can easily solve this thing. This is nothing but 1.6 modulus of 3.2 and minus 4.8. So distance between these two, it's 1.6. That's how you can think if you want. And then least integer value of positive 1.6, it's going to be 2. Yes guys, are you all with me? Once again, see, in marathon session I'll keep charging you, so show me a thumbs up if you all have understood. And yes, do not forget to press the like button, right? It's a compulsion, it's a mandatory thing, it's a ritual. You know, when you attend my sessions, एक finger तो आपकी like button पे पहले ही चली जानी चाहिए. Right, great. Okay, so let's take up a couple of more questions which will again enhance your understanding to this concepts of modulus and number system, the number line particularly. So here you need to put one of the signs, okay, and this cross indicates can't be decided. So you are given that mode of x is less than mode of y. So what can you say about y and x? So guys, if I take x as 3 and y as 4, so again this condition is satisfied. Mode of x is yes less than mode of y, and in that case y is greater than x, right? In this case, of course, we can say y is greater than x. But what if I take x as 3 and y as minus 5? Again, can I say mode of minus 5 is going to be 5, so mode of y is greater than mode of x. So I am satisfying this condition, but y is now less than x. For this one, y is less than x. So can we decide which relationship exists between these two? No. So we will put a cross sign here. Yes, everyone? We will put a cross sign here. Have you all understood this part? Great. Okay, so one more question, similar question. It's slightly tricky. Now here it says that mode of x is less than y. So take values of x and y such that mode of x is less than y. Now you know that mode of x can't be negative. So y has to be positive, that's for sure. Because y is greater than mode of x and modulus is always non-negative. So y has to be positive. So you can't take negative value for y over here. So if I take x as 3, so y has to be 4, or even I can take 3.1. Y can be 3.1. So mode of 3 will be less than 3.1. Yes, in that case mode of 3.1 will be greater than mode of 3 for sure. Same way you check for any other value, ultimately you are going to get greater than sign. So we can surely say this mode of y will be greater than mode of x if you are told that y is greater than mode of x. Robin, for this question, if you are talking about this question or even for previous question, please understand mode of x is less than y. So if you assume both as 0, 0, so of course it will become equal. We need to satisfy this relationship. We need to assume the value such that it satisfies this relationship. So if I take x as 0, I'll have to take y as 1 or 0.1 or something like that. So ultimately mode of 0.1 is greater than 0. So this relationship is always going to be true. Are we clear with this? Okay, fine. So let's move to the next part. In fact, there's one more tricky question. So, the common mistake that students make, A is greater than B. So if I take A as 4, B as 3, then what is 3 by B and 3 by A? So of course, this will be 3 by 3 and this will be 3 by 4. So we might be tempted to put a greater than sign. In fact, you take any other number, this would be true. Only if you are taking positive number. What if I take number like this one? Let me take A as 3 and B as minus 1. Now 3 upon minus 1 and this is 3 upon 3. So of course this will be greater, right? So that's why again we can't decide what will be the relationship. Okay, everyone, have you all understood this? Great. Okay, so this is the marathon session on number system. In 3 hours, you are going to complete your number system of CAT. right? And we are going to practice plenty of questions. Some of them have been asked even in CAT exams. Okay, so yes, please be with me. Now this question, so y equal to all odd numbers up to 21 terms. So the simple concept, sum of 21 odd numbers, sum of 21 odd numbers is going to be odd, and cube of odd is also going to be odd. So this result will be odd. So then is y odd? Yes, it's going to be odd. Correct? So this was a simple question. Okay, let's take some digits related situation. So before that, let me quickly tell you, when you assume a 2-digit number as AB, yes, the value of that 2-digit number will be 10a plus b, and you perform mathematical operation like multiplying by something or adding something on its value, not on this one. So don't write AB plus 5, this is incorrect. It has to be 10a plus b plus 5. So this is how we solve this question. Same way, if it's a 3-digit number ABC, then the value will be 100a plus 10b plus c. Guys, are we all clear with this? Everyone, show me a thumbs up about this digit related problems. Great. So let's try to solve this question. When a 3-digit number was written on the right hand side of a 2-digit number, to create a 3-digit number, then the new number, that is the 3-digit number, found to be 372 more than the previous number. Okay, so let me take a 2-digit number. First of all, I created a 3-digit number by putting 3 on the right hand side. Okay, so at the units place. So now this is a 3-digit number and this 3 is at the units place. Great. Okay, and this number found to be 372 more than the previous number. Okay, so if I add 372 to this number, I should get this number. But then we need to perform mathematical operations on the value. So let me just write down the value of this 10a plus b, and let me write down value of this one also. It's 100a plus 10b plus 3. Now this number is 372 more than this number, so let me add 372 in this number, so then it will become equal. Both the sides will become equal, right? Now we need to solve this thing. So take this 3 on this side. So 372 minus 3 is what? 369. And 100a minus 10a, it's 90a. And 10b minus b is plus 9b. Right? Divide the complete equation by 9. If you divide it by 9, then what will happen? What will you get? 10a plus b. This will become 10a plus b equal to 41. And what are 10a plus b? It's the value of the number which is given as 41. So can I say a b should be 41? Or you can think it this way: if I take a as 4 and b as 1, only then 10a plus b will be 41, because a and b are the digits and the value of digits will be always 0 to 9, right? So this is how we got this number as the initial number, original number as 41. So what is the sum of the digits? It's 5, right? Great. So we are trying to revise all the different types of concepts in this 3-hour marathon session, guys. So yes, you are going to be sure of the complete number system, and then after this session maybe you can try solving some CAT questions related to numbers. I'm sure you will be able to apply few of these concepts. Okay, fine. So now let's start with this second part, factors and divisibility. So we are going to spend almost 30 minutes on each area. In fact, divisibility, HCF, LCM, we may spend a little more time because there are so many concepts in that. But yes, our objective is to make everything clear. So once again, what are the factors of a number? Factors of a number are the numbers which divides the given number. So which number divides 12? What are the factors of 12? Do not forget to include 1. So it's 1, 2, 3, 4, 6, 12. So these are the factors of 12. What are the multiple of 12? Multiples of 12. So numbers which are divisible by 12, or you can say numbers which come in the table of 12. 12, 24, 36, 48, and so on and so forth. Remember, it goes till infinity. So these are the multiples, and HCF LCM is completely based on this factors and multiples. In fact, the numbers which have just 2 factors I'll call prime numbers. So prime numbers have only 2 factors, and composite numbers have more than 2 factors. So composite numbers have more than 2 factors. I'll just write it this way: more than 2 factors. Please remember, 1 is neither prime nor composite. 2 is the first prime number, then all other prime numbers are even. So 2 is the first and only even prime number, right? So you understand this part. And then as I had explained earlier, a composite number is nothing but composition of prime numbers, right? So composite number is nothing but composition of a prime number. So if I look at some composite number, say 12, so how is this 12 formed? So it's by multiplying this prime number. So if I look at number 9, how is this number 9 formed? It's by multiplying the same prime number twice. So every composite number can be represented as the in the form of its prime factors, and that is called prime factorization. Now before we go ahead with prime factorization, guys, let me once again quickly tell you some of the benefits of this plus subscription. So you get access to this mock test for various MBA entrance exam. You will get access to regular leaderboard in the session. There will be regular revision and doubt solving session. So you'll get personal attention. So yeah, what you need to do for that is you need to quickly go to Play Store or App Store, download the Unacademy app, install it, and then select plus and select your goal, that is CAT. And then if you click on the subscription, so you will be shown various plans. Go for this 1-year plan or 2-year plan using my code, which is SHAH10, right? So use this code SHAH10, do not forget to do it. Correct. So guys, coming back to this prime numbers, so before we go ahead with prime factorization, let me quickly tell you that prime numbers are those numbers which have just 2 factors, and composite numbers are those numbers which have more than 2 factors. In fact, composite numbers are composition of prime numbers. Okay, now before that, please remember this prime numbers between 1 and 100. So these are the prime numbers between 1 and 100 which I have highlighted by yellow color. There are in total 25 prime numbers from 1 to 100. And you can also remember this breakup. Fine. Talking about prime factorization, so as I mentioned earlier, 12 is nothing but 2 into 2 into 3, or I can represent this as 2 square into 3 raised to 1. Same way, if I take a slightly bigger number, say 60. So what is 60? It's 2 into 2 into 3 into 5, isn't that? You can also think it this way, 10 into 6 is 60. So what is 10? 2 into 5. What is 6? 2 into 3. So how many times will 2 appear in 60? 2 times. 3 1 time, 5 1 time. So this is the prime factorization of 60. Correct. So this is how we can represent. In fact, this is the prime factorization of 360. 2 raised to 2, 3 raised to 1, 5 raised to 1. So in general, any number, any composite number n can be represented in this form: a raised to p, b raised to q, c raised to r. And this way of representing a composite number is called prime factorization. Remember this, a, b and c are nothing but prime numbers, prime factors of n. Okay, and this is p, q, r are the power of that prime factors, right? Okay, fine. Now before we go ahead with test for prime numbers, guys, you can also note down this formula, that once you have represented in the prime factor form, prime factorized form, then number of factors of n is equal to this power plus 1 into this power plus 1 into this power plus 1, or I can say p plus 1 into q plus 1 into r plus 1, and so on and so forth. So what is the prime factorization of 12? It's 2 raised to 2 into 3 raised to 1. So what are the powers? 2 and 1. So how many factors will 12 have? 2 plus 1 into 1 plus 1. That is total 6 factors. And as we have seen earlier, that there were 6 factors of 12. So if I give you a bigger number like 3600 or 360, you can quickly find out the number of factors. And even questions based on this concept have been asked in CAT exam. So I'll give you one question related to this one. So everyone, try for this question. Can you tell me how many factors, try to solve this question, how many factors of 3600 are divisible by 6? How many factors of 3600 are divisible by 6? This is one question. And then the other question, how many factors of 3600 ends with 10? How many factors of 3600 ends with 10? So these are the two questions that you need to solve. Can you quickly tell me the answer for this one? Guys, are you all with me? Show me a thumbs up first of all if you are still alive, if you are with me. Okay, show me a thumbs up. And then, yeah, then solve this question. How many factors of 3600 are divisible by 6? This is what you need to find out. So कैसे find करेंगे? How will we do it? And then the second question, how many factors of 3600 ends with 10? So we need to solve these two questions. Guys, both of these are CAT question straight away. Okay, so let's see whether you are able to think that way or not. Robin is saying 15. Okay, there are 15 factors which are divisible by 6. Is it, Robin? So let me check. 4 and 2, 8, and these are 24. I think it should be 24. See, please understand what is the prime factorization of 3600. What is the prime factorization of 3600? Everyone, let's quickly understand that first. And I'm also going to teach you a different concept. Okay, so first let's look at prime factorization of 3600. It is 2 raised to 4, 3 raised to 2, and 5 raised to 2. Yes or no? Because 3600 is nothing but 36 into 100. As you know that 10 is 2 into 5, so 100 is 2 square 5 square. So this 100 is 2 square 5 square. 36 is 2 square 3 square. So total power of 2 is 2 raised to 4, 3 raised to 2, and 5 raised to 1. Right? Okay, now guys, let me help you understand how did we get that formula p plus 1. Let's erase this question for timing. Let's put this question aside. We'll come back to this question. But how that formula came, p plus 1 into q plus 1 into r plus 1, and so on and so forth. How did this formula come? So guys, it's like this one. The factor or the number which will divide 3600 consists of only 2s, 3s, and 5s. Okay, it will be consisting of 2s, 3s, and 5s. So for example, if I take a number 5 into 7, 35, will it be a factor of 3600? Will 3600 be divisible by 35? No, because 3600 doesn't have any 7 in that. So we can't use 7 and other prime numbers. We need to create numbers using only this 2, 3, and 5. Okay, and what is the maximum power of that 2, 3, 5 that we can use? Up to 4, up to 2, up to 2, right? So let me help you understand this concept. So guys, the number of ways in which I can choose 2, and number of ways I can choose 3, and a number of ways I can choose 5. See, I'm using a bit of counting principle here. Now counting principle is a very simple concept which I'm going to explain tomorrow during that marathon session of permutation combination, but still you can understand this way. Okay, I can take any power of 2 from 0 to 4, 0, 1, 2, 3 up to 2 raised to 4. So there are 5 different powers that I can choose from, right? Same way, see, ultimately whatever factor I am creating for 3600 can have 2, can have 3, can have 4, but not necessary that it will have 2. It can only have 3 and 5 also. Okay, so we can take 0 power of 2 also. That means we are not taking any 2s in that. Correct? Same way, what are the different power of 3s that I can choose? So I cannot choose 3. That means I am choosing 0 power of 3, or I can choose 1 power, or I can choose 2 powers. So that's why total number of ways in which I can choose 3 is 3, right? And total number of ways in which I can choose 5 is, I can choose 0 power of 5, 1 power of 5, or 2 power of 5. So I can again choose it in 3 ways. So total number of factors of 3600 is this power plus 1, that is 4 plus 1, 5, into this power plus 1, that is 3, into this power plus 1, that is 3. So it will come out to be 45. Now out of this 45 factors, we want to find out the number of factors which are divisible by 6, right? Now a factor which will be a multiple of 6 or divisible by 6 will have at least 1 2 in that. So it should have at least 1 power of 2. It can have more power, but it should have at least 1 power of 2, and it should have at least 1 power of 3. Yes or no, guys? Have you all understood this part? Just show me a thumbs up if you have understood. What I'm saying is 6 is nothing but 2 into 3. So if I'm trying to find out the factor of 3600 which is divisible by 6, so it should have at least 1 power of 2 and at least 1 power of 3. Whether it has 5 or not, that doesn't matter, right? So now the number of ways in which I can choose 2 is 3, number of ways in which I can choose 3 is 2, and number of ways in which I can choose 5. So there is no restriction on 5, so that will be 3. So total number of factors of 3600 which are divisible by 6 are 18, right? There are 18 factors. Let me tell you what are those 18 factors. Let me just write down over here. So what powers of 2 am I choosing from? 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. Same way, what power of 3 that I'm using? Either 3 raised to 1 or 3 raised to 2. What power of 5 I'm choosing? 5 raised to 0, 5 raised to 1, 5 raised to 2. Now let me create different factors. Okay, let me show you this thing with some design, and you will understand this concept, right? You will understand this concept. So suppose I am taking this power of 2, that is 2 raised to 2, and I am taking 1 power of 3, that is 3 raised to 1, and I am taking 1 power of 5, that is 5 raised to 1. See which number is formed. 4 3s are 12, 5s are 60. Can I say, of course 3600 is divisible by 60, that means 60 is a factor. Same way, if I take 2 raised to 4, 3 raised to 2 and 5 raised to 0, what number will be formed? So 2 raised to 4 is 48, 3 raised to 2 is 2 raised to 4 is 16, 3 raised to 2 is 9, so 16 nines are 144, and 5 raised to 0 is 1. So even if I form this number 2 raised to 4, 3 raised to 2, 5 raised to 0, this number will surely be a factor of 3600. Please check. Guys, are you getting this point? Have you all understood this point? Everyone? Are you all clear with this one? The one that I have shown? Great. Okay. Fine. Sure. So this is how you can solve the questions. So same way, if I ask you this question, how many factors of 3600? Once again, let me write. How many factors? In fact, if you didn't understand that concept, you will understand it now, guys. So I'm taking similar question. How many factors of 3600 ends with a 0? With a 0. So can I say a number ends with a 0 when it has at least 1 power of 2 and at least 1 power of 5, right? So once again, I know the prime factorization of 3600. It's 2 raised to 4, 3 raised to 2, 5 raised to 2. So that means earlier I used to choose this power 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. I can choose any power of 2 from this if I want to create a factor. Same way, I can choose any power of 3 from this powers, and I can choose any power of 5 from this one if there is no condition. But now we want the factor to end with a 0. That means it should have at least 1 power of 2 and it should have at least 1 power of 5. So number of powers of 2 that you can choose are this one. So you can choose any one of these 4 powers. There is no constraint on 3, so you can choose any power of 3. And number of power of 5 that you can choose is 5 raised to 1, 5 raised to 2. So only 2 powers. So total number of factors which will end with 0 will be 24. How many total factors are there? 45 total factors are there. Total factors are 45. Out of them, 24 factors will end with 0. Right? So answer for this one is 24. Yes, guys, someone is asking a question. So, but to be divisible by 6, we need to consider only 2 and 3. No, Robin, see, please understand, if I take a number like this one, 2 into 3 into 5 raised to 2, is this number not divisible by 6? Yes, it is divisible by 6. So for a number to be divisible by 6, it should have at least 1 2 and at least 1 3. If it has additional things, so for example, if I take a number like 2 raised to 2, 3 raised to 1, 5 raised to 1, even this number will be divisible by 6. Yes or no? Right. So for a number to be divisible by 6, it should have at least 1 power of 2 and at least 1 power of 3. Now if it has more than 1 power of 2, more than 1 power of 3 and something else also, that's perfectly fine. That number will be still divisible by 3. Are we all clear now? Show me a thumbs up if you are with me. Everyone? Who all are present? So once again, let me see. Where is Rajat? Shubhankar, Rajat, Arunima, they are missing today. It looks like they're sleeping. Okay, so let's quickly learn and let's score some more percentile, guys. है ना? Fine. So now quickly let's look at test for prime numbers. So as you remember, if a number n is divisible by a prime number less than root of n, then n is a prime number. Just to simplify once again, if I take a number like 199, whether it's prime or not, what you need to do is identify the nearest perfect square number 196, take the square root of that 14, divide 199 by the prime numbers between 1 to 14. So which are the prime numbers between 1 to 14? 2, 3, 5, 7, 11 and 13. If 199 is divisible by any of this number, that means it's a composite number. If it is not divisible by any of this number, that means it's a prime number. Is that clear? Yes. Okay. So let's quickly look at HCF, LCM. So HCF is the highest number that divides both the given number. LCM, smallest number which is divisible by both the given numbers. Right? So we have understood this thing. Right? So if I ask you to find out HCF, LCM of 12 and 18. So first for HCF, you will write down factors. So factors are 1, 2, 3, 4, 6, 12. Yeah. 18 factors, 1, 2, 3, 6, 9, 18. Then look at the common factors. So common factors are 1, 2, 3, 6. Yes or no? Now highest among them, it's 6. So 6 is that highest number which divides both the given number. Same way, if I ask you to find out LCM, you look at the multiples of both the numbers, 24, 36, 48 and so on and so forth, 60, 72. Then you look at multiple of this one, 36, 54, 72 and so on and so forth. So multiples will go on till infinity for each of this number. Okay, please remember. Now we need to look at common multiples. So 36, 72, 108, again infinite common multiple. The lowest among them, 36. That's the LCM. So this is the conceptual understanding of HCF, LCM, right? But how do we find HCF, LCM? So I have shown you certain shortcut. So this is what I'll show you once again. What are the shortcuts? We'll come back to that. But before that, just remember HCF of fraction you can find using this formula. LCM of fraction you can find using this formula. Okay, LCM of numerator upon HCF of denominators, right? What are the co-prime numbers? Numbers whose HCF is 1. In simple words, if there is no common prime factor, no common prime factor is there between two given numbers, they'll always be co-prime, or more than two numbers also. So for example, 8 and 15. What is 8? It's 2 into 2 into 2. What is 15? It's 3 into 5. Do you see any common prime factor between this? No. So they are co-prime. But instead, if I take 15 and 27, what is 15? 3 into 5. What is 27? 3 into 3 into 3. Can I say 3 is common in both? So they are not co-prime. Right? So co-prime numbers have HCF 1. And if two numbers are co-prime, their HCF is 1 and LCM will be straight away product. So what is LCM? What is the common multiple of 8 and 15? It has to be 8 into 15, that is 120. Guys, so this is how, once you have identified co-prime numbers, you can quickly find out that HCF and LCM. HCF is of course 1 and LCM is product. Okay. Now please remember, two successive numbers are always co-prime. So 10, 11 or 20, 21, or if you take 15, 16 or any two successive numbers, they'll always be co-prime. Right? So what are the shortcuts to find out HCF, LCM? But before that, since we are discussing co-prime numbers, so we must look at the Euler numbers. So Euler numbers for co-prime. So guys, there is a concept, so for example, phi of 30 means number of co-primes less than 30. Number of co-primes to 30 less than 30. तो कितने नंबर ऐसे हैं 30 से छोटे, कितने नंबर ऐसे हैं जो 30 को को-प्राइम है? तो अगर आपको ये फाइंड करना है तो आप ये phi of 30 यूज कर सकते हो और इसको ऑयलर्स फॉर्मूला कहते हैं. और इसके लिए फॉर्मूला क्या है? सो phi of n is equal to n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c and so on and so forth. Now what is this ABC? So before that you must have represented a in n in this form, a raised to p, b raised to q, c raised to r. So that means you have identified the prime factors of n, and then you can quickly find out this way. So what is 30? So 30 is nothing but 2 raised to 1, 3 raised to 1, 5 raised to 1. So the prime factors of 30 are 2, 3 and 5. So what is phi of 30? Just apply that formula. 30 into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. Yes guys, can we do it this way? Are you all with me? Show me thumbs up quickly. Yep, show me a thumbs up, everyone. Right. So if you solve this thing, what is 1 minus 1 by 2? It's 1 by 2. 1 minus 1 by 3, 2 by 3, 4 by 5. So if we just solve, it will come out to be, right? It will come out to be 4 by 15 into 30. So this is nothing but 8. Yes, everyone? Okay, so it's a time for me to have a sip of tea, right? Cheers. In fact, you can also have, as I mentioned, make sure that you have your water bottle with Tang or Glucon-D in that, or if you want, you can have cup of tea also. See guys, marathon session, it's going to be quite chilling out because we want to seriously revise everything in about 3 years time, right? And yeah, there's no point in continuously just learning for 3 years. We need to have something in between also, right? So you can also order some samosa or something on Swiggy if you want. So that's perfectly fine. Don't show me, otherwise I'll feel tempted. Okay guys, fine. So I hope you have understood this Euler numbers. Great. Now let's quickly understand this shortcuts for HCF and LCM. Right, so there were few shortcuts that I had shown that, for example, if I ask you to find out HCF LCM of such numbers, so what you can do is or let me take some other number, right? Something like 60. So you can always look at the difference between the numbers and you can make out what can be the HCF. So here the difference is 24. Check whether both the numbers are divisible by 24. No. So strategic timeout. Okay. Yes, Akash. बड़े आईपीएल के फैन हो यार तुम, है ना? तो शायद इस बार तुम बड़े दुखी हो गए, आईपीएल तो कैंसिल हो गया. Okay. So 24 is not the HCF of these two numbers. So now look at the factors of 24, that is 12, 8, 6, 4 and so on and so forth. HCF will be one of this, right? We can quickly think in our mind and we can make out, okay, this has to be the HCF. If I just check both the numbers are divisible by 12, so yes, HCF is 12. So this is one shortcut for HCF. Same way, once you have found out HCF for two numbers, say 84 and 60, so for LCM we can use that method of co-prime method for HCF LCM, right? And what is that method? Yeah, what is that method? So it's 12 into 5, represent both the numbers in terms of that HCF. So 12 into 5 and this 12 into, sorry, this is 12 into 7 and the second one will be 12 into 5, right? So 12 is the HCF and the testimony of that, the proof of that is this two parts should be co-prime. This two parts should be co-prime. That means this 12 is correct HCF. Now what is the LCM? So draw that reverse L. Draw reverse L. So LCM is 12 into 7 into 5. Have you understood this? So this is the method of co-prime to find out HCF LCM. Same way, if I take 35 and 45, by looking at the number itself, I can make out 5 is the HCF. So what will be the LCM? So first, write this way, 5 into 7, 5 into 9, and these two are definitely co-prime. Yes. So now LCM will be 5 into 7 into 9. Yes, everyone, can we do it this way? Quickly, HCF LCM. So you don't need to use that method, the one that you used to use in school, 84, then 60, divide by prime numbers, 2, 42, 230. Guys, it will take so much of time, right? And that is what we know or do not have during the exam, the time, right? We have very limited time. Yes, okay. So let's move forward quickly, everyone. And yeah, some more HCF LCM related shortcuts. So if I ask you to find out HCF LCM of these numbers, say 120 and something like 220, find HCF LCM. So since both the numbers have a 0, put that 0 aside, find out HCF LCM of 12 and 22, right? So HCF, by looking at the number itself, you can make out it's 2, right? And LCM, so now this is 2 into 6, this is 2 into 11. If you check, 11 and 6 are co-prime, so that HCF is correct. So LCM will be 2 into 6 into 11. And now whatever HCF you have got, just put this one behind. So this will come out to be 20 and 1320, right? So these are the HCF LCM. Okay, these are some of the shortcuts. Fine. And for two numbers, please remember this point: HCF of two numbers and LCM of two numbers. The product of HCF and LCM is equal to product of two numbers. So for example, 12 and 18, HCF is 6, LCM is 36. So 12 into 18 is equal to 6 into 36. Both will come out to be 216. See, that's true, right? Then quickly the divisibility test. So for 2, check for last digit. For 4, check for last 2 digits of the number. For 8, check for last 3 digits of the number. For 3 and 9, we check for sum of the digits of the number. If the sum of the digits is divisible by 3, then the number will be divisible by 3. If the sum of the digits is divisible by 9, then the number will be divisible by 9, and so on and so forth. Yes, okay. Then for 5, 10, of course, last digit, that is sufficient to understand. For 6, remember it's 2 and 3. If number is divisible by both 2 and 3, it will be divisible by 6. Same way for 12, do not make that mistake. It's not 2 and 6, it's 4 and 3. Yeah, it's 4 and 3. Correct? Everyone, have you understood this? Yes, fine. Now two more tests, 7 and 11, right? So let's discuss this 7 and 11 here itself before we go ahead for the commercial break. So for 7, you check for the last digit and make it double. So in fact, the test for 7 is something like this. Suppose 343 is that number. You want to check whether it's divisible by 7 or not. So check the last digit, it's 3. Make double of that, so it's 6. I'm making it double, 6. Now subtract that 6 from 34 and see if the result is divisible by 7, then the whole number will be divisible by 7. Keep doing till the time you get a result which you can make out whether it's divisible by 7 or not, right? Same way for 11, the test for 11 is check for alternate digit sum and difference. So A, B, C, D is a 4-digit number. Now what you'll do is you'll pick alternate digit and you will add them. So A plus C. Take again alternate digits and add them, B plus D, and check this difference. If it's 0 or 11, the number will be divisible by 11, right? Now once again about the subscription. So these are some of the subscription plan of Unacademy. So you can keep learning on YouTube and you can also learn on Unacademy platform. So for that you need to take subscription. In fact, you will also get mock test series and leaderboard and personal doubt solving and all. So go for one of this plan. Do not forget to use my referral code, which is SHAH10, right? So if you want to note down this thing, it will get you 10% discount and you will also be able to follow me there. Okay, so HCF LCM, guys, can you quickly tell me HCF LCM of this 4 numbers? Now I have showed you plenty of shortcuts, so please find out HCF LCM of these numbers, everyone. Guys, in fact, what you can do is all of you can just take a screenshot of this slide. Of course, I'll give you PDF of this, and the PDF will be available by tonight, and tomorrow we will be posting the link in every lecture description, every session description. So you will be able to download all the PDF from session number 1, right? So what you can do is you can take screenshot of this one and please post it on your Facebook page. Please post it on the Facebook page along with one of the video link. So that will be a good favor for me. Right, now find out HCF LCM of these 2 numbers, all these numbers rather. So here of course it will be 5 and then LCM will be 5 into 7 into 9. This is how you should be able to quickly find out. Here HCF, by looking at that I can make out it's 20 and LCM will be 20 into 7 into 12, whatever it comes. Because see, 140, 240, of course 20 is the common factor. You can make out this thing, right? So both the numbers are divisible by 20. So this is nothing but 20 into 7 and this is nothing but 20 into 12. So LCM will be 20 into 7 into 12. So this is what I'm directly writing and this is what you should also be able to do. Yes, okay. Same way for these 3 numbers. Now here once again let me explain a shortcut: 48, 84 and 96. So HCF, of course you can observe the difference. The smallest difference is 12. Check whether all numbers are divisible by 12. Yes, they are. So HCF has to be 12. Now when you find out LCM, you don't need to look at 48 because 96 itself is a multiple of 48, right? 48 to the 96, right? So that's why when we find out LCM, we just need to look at LCM of these two numbers. We need to find out LCM of these two numbers, and we know this HCF is again 12, you know, so this is 12 only. So 84 is 12 into 7, 96 is 12 into 8, so LCM will be 12 into 7 into 8. So this will come out to be 12 and 12 into 7 into 8. I'm just writing it in this form, then you can solve it, you can multiply it on your own. Same way, this is pretty simple, 30 and 1800. Guys, have you all got these answers? Quickly show me a thumbs up if you are clear, if you could find out with this speed. Yes, everyone? Quickly tell me, have you all got this answer? Great. Fine. Even I need to recharge myself, okay, continuously, so that we can go ahead with the same enthusiasm. Okay, so this question is solved, guys. I have already given you that formula, phi of 30. So now you understand the formula. Okay, what about this question? Everyone, can you try to solve this question? Two-digit numbers have GCD 6 and LCM 432. Which is the greatest of the two numbers? You know, so this is a special case. I mean, you can of course do it by trial and error, but then we can follow a systematic approach. Please pay attention in case if you're not clear about this. Guys, if I take two numbers like say 12 and 18, very simple two numbers, 12 and 18. Of course, I know that HCF is 6. So can I write down 6 as 6 into 2 and 18 as 6 into 3? Yes or no? So in this case, what will be the LCM? Of course, it will be 6 into 2 into 3. Correct? So same way, let me assume here two numbers as A and B. And I know that HCF is 6. So these numbers can be represented. GCD is nothing but HCF. So HCF is 6. So this number let's assume as 6 into A and this number will be 6 into B. Please remember these two have to be what? What do you think need to be? Co-prime. Yes. So these two have to be similarly co-prime. Correct? Yes. Okay. Now what will be the LCM? Can I say it will be 6 into A into B? And LCM is given as 432. I can say 432 is equal to 6 into A into B, or I'll get A into B as 72. Once again, they have to be co-prime, to split 72 in two parts which are co-prime to each other. So of course 8 and 9, of course we can also do it 1 into 72, but if you go by this, our numbers will not be of two digits. So that's why we'll have to take 8 and 9 as A and B. So my numbers will be now 6 into 8 and the other number will be 6 into 9. So I got these two numbers, 48 and 54. Have you all understood? Yes, guys? Great. So this is how we can quickly find out HCF and LCM. In fact, we can apply that concept of method of co-prime to solve this kind of questions, right? It should not be a challenge. See, we have revised many concepts up till now, right? We have completed number line, modulus, and greatest integer, least integer. Then we have also discussed divisibility, HCF, LCM, along with the minor concepts like prime factorization, number of factors, Euler numbers, and then shortcuts for HCF, LCM also, along with divisibility test, right? So this is what we have discussed up till now. So let me show you a few more questions. If you can tell me the answer, please solve this question and type the answer in the chat box quickly. Everyone, if you want, you can pause it here and you can do it, and then you can verify your answer with me. So this is how you can solve this question. So find the least number which when divided by 20 or 25 or 40 leaves remainder 2 in each case. Find the least number which when divided by 20 or 25 or 40 leaves remainder 2 in each case. How can you do it? How can you find out? what we need to do over here? We need to find out LCM first, guys. Least number which is divisible by 20, 25, 40 means you need to find out LCM of 20, 25 and 40. Right? So what is LCM of 20, 25, 40, guys? Isn't that 40? Oh, sorry, isn't that 200? Right, so answer is 202. The correct answer is 202 because the LCM of these numbers is equal to 200, and then you see 200 is perfectly divisible by this, but we want 2 to be the remainder, so add 2 to this, so it will come out to be 202. What about others? Varshini, Nicole, Robin, what about you? Have you all understood this? Show me a thumbs up if you are still there, if you are alive. Yeah. Same way, one more question. Find the least number which leaves remainder 2 when divided by 5. So this is slightly different question. See, it leaves remainder 2 when you divide by 5. It leaves remainder 5 when you divide by 8. And it leaves remainder 7 when you divide by 10. So here, if you observe, there is a pattern, and that's why I have once again taken this question. So, you know, during this marathon session, I have taken some important questions which are slightly tricky and all. Okay. So guys, the divisor and remainder, let's write it this way. So when I divide by 5, the remainder is 2. When I divide by 8, the remainder is 5. When I divide by 10, the remainder is 7. If you observe here, the difference between divisor and remainder is 3. The difference is 3. Yep. Okay, so in such question, you will take LCM of this number, the divisors, and you will subtract the common difference from that LCM. Okay, please understand. LCM of these numbers and subtract 3 common difference from them. Now, why are we doing it this way, guys? Please understand. Now, this is conceptual. Let's understand this part. There is a number which, when we divide by 5, it leaves remainder 2. Okay. So, matlab, that number is 2 more than multiple of 5. Which are such numbers 2 more than multiple of 5? Can I say 12 or 17 or 22 and so on and so forth? So, all these numbers, can I say 3 less than multiple of 5 as well? All these numbers are nothing but 3 less than multiple of 5 also, na? So I can say they are 2 more or they are 3 less. So in the previous question, if you observe, in each case it was leaving remainder 2. So we found out the LCM and we added that. Here in each case, they are 3 behind the multiple of this one. So that's why I have taken LCM and I have subtracted 3 from that. Are you getting this point? Yes. So this is the difference between previous question and this question. Over there, it was leaving remainder 2 in each case. Over here, it is 3 behind the next multiple of each of this divisor, right? थोड़ा सा इसको सोचना बाद में. Guys, this question, try for this question. Chalo, quickly. Ram takes 6 minutes while Lakshman takes 7.5 minutes to take a walk around a circular garden. If they start together at 10 a.m. from the same point in the same direction, at what time will they be together at the starting point, right? So guys, this is in a way you can say circular race question. Let me draw it. So both of them started from here, this point. This is the starting point. Ram and Lakshman. Can I say Ram takes 6 minutes? So Ram will keep coming to the starting point after every 6 minutes. Suppose both of them started at 12 o'clock. Okay. Afternoon walk के लिए निकले थे. Okay. अच्छा 10 a.m. 10 a.m. दिया हुआ है. Morning walk ही है. So both of them started at 10 a.m. Right? So Ram will keep coming at the starting point at after 6 minutes, then 6 more minutes, that is 12 minutes, 18 minutes, 24 minutes, 30 minutes, and so on and so forth. Same way Lakshman will come for the first time. So he'll take 7.5 minutes. So I'll say 7.5, then double of 7.5, that is 15.5, then 22.5, and then 30. So can I say both of them will be together after 30 minutes? That is 10:30 they will be at the starting point again. Now what is this 30? It's nothing but LCM of 6 and 7.5. Now the question is, how do we find it? So yes guys, we know how to find out LCM of fraction. Consider 6 as 6 by 1 and 7.5 as 15 by 2. So LCM of fraction is equal to LCM of numerators. Okay, so what is 6 and 15 ka LCM? It will be 30. Divide by HCF of denominators. So what is HCF? It's 1, so it will come out to be 30. So this is how we found out LCM of fractions. Correct, everyone? Yeah, fine. So let's look at this question. This is again application of LCM. The only thing is you will have to just understand, you will have to convert those seconds to minutes and so on and so forth, or minutes to seconds. So 5 bells toll together. Toll means ring together. Suppose at 12 o'clock I started all the 5 bells. Let me call them A, B, C, D, E. So all of them I started. When I started them, they made a noise, they made a sound, ton. And now the first bell will keep ringing after 3 seconds, 6 seconds, 9 seconds, and so on and so forth. The second bell will keep ringing after 6 seconds, 12 seconds, and so on and so forth. The third bell after 12 seconds, 24 seconds, and so on and so forth. And the fourth bell, so these 6, third bell is 9 seconds. So third bell will keep ringing after 9 seconds, 18 seconds, and so on and so forth. Fourth, 12, 24, and so on and so forth. And fifth, 15, 30, and so on and so forth. So can I say all of them will ring together at a time, which is LCM of this numbers 3, 6, 9, 12, and 15. A number, a time which is LCM of all of this. So what is LCM of this numbers? It's 180. 180 what? Seconds. So 180 seconds means 3 minutes. So all of them will ring together, after 3 minutes. Okay. So 12 3 को वो पहली बार साथ में रिंग करेंगे, तो 30 मिनट्स में और कितनी बार रिंग करेंगे? 10 बार रिंग करेंगे कि नहीं? हर 3 मिनट में वो साथ में रिंग करते रहेंगे. So in 30 minutes they'll ring for 10 times. Yes guys, have you all understood this? Pakka, show me a thumbs up quickly if you are clear with this point. Great. So now are you all ready for the remainder concept, guys? So in the remainder, let's quickly understand few basic things, right? So the first thing is, of course, if I want to divide 94 by 8, what is the remainder? Definitely 94 divided by 8, remainder is 6, correct? But this 94 can also be written as 50 plus 44. So now we need to divide this 50 plus 44 by 8, correct? So now what you'll do is you'll individually divide this number. So 50 divided by 8, remainder is 2, 44 divided by 8, remainder is 4, and since these two numbers were in addition, so you will add this remainder, again you will get your remainder as 6, correct? Same way 94 can be written as 47 into 2. So if you want to divide this by 8, what you'll do is you will divide 47 by 8, so it will produce remainder 2. 2 divided by 8, smaller number divided by larger number, remainder is the number itself. So now you got 7 into 2, 14 as the remainder. But 14 can't be the remainder because the remainder has to be less than the number. So you will divide this 14 again by 8, and again 14 divided by 8, remainder will be 6. So this is what you need to understand in the remainder concept, that if two numbers are in addition, you will individually divide them by the divisor and you will add the remainders. If two numbers are in multiplication, you will individually divide them by 8 and you will multiply the remainders, right? So guys, if I give you a question like this one, 9 raised to 90 divided by 8, what is the remainder? 9 raised to 90 divided by 8, what is the remainder? Can I say 9 raised to 90 is nothing but 9 into 9 into 9 up to 90 times, and each of this 9 when divided by 8 will produce remainder 1. So 1 into 1 into 1, 90 times, so we can straight away write 1 raised to 90 divided by 8, right? So whenever I give you such questions, suppose I give you a question like 11 raised to 90 divided by 8, what is the remainder? So you can simplify this question as 3 raised to 90 divide by 8 and finding the remainder. This question 11 raised to 90 divided by 8 is similar to solving 3 raised to 90 divided by 8. Are you all clear with this? Correct? Can you apply this concept? Okay, fine. So let's look at concept of negative remainder, which is very useful in solving high power remainder question. So I'll give you one thumb rule that when you want to solve high power remainder question, you will always try to get remainder 1 or minus 1. So for that we'll require negative remainder concept. So what is 12 divided by 5, guys? It's 2, because 12 is 2 more than some multiple of 5. Same way, what is 11 divided by 5? Of course, again remainder is 1. Very simple question. You might be wondering, sir, why are you asking this question? In fact, 10 divided by 5, what is the remainder? So of course remainder is 0, because 10 is just multiple of 5, so it's completely divisible, so remainder is 0. 9 divided by 5, what is the remainder? Now can I say the remainder is minus 1? Because 11 is 1 more than multiple of 5, so you can say 9 is 1 less than multiple of 5, so remainder has to be minus 1, right? This is also true. So same way, if I ask you 13 divided by 7, what is the remainder? So you can say the remainder is 6 or it's minus 1. You know, when you add this negative remainder to the divisor, you will get your positive remainder back. If you add this minus 1 to 5, you will get your positive remainder 4. So that's always there, but you can also write minus 1. Now where can we use this concept? So guys, if I ask you this question, 30 raised to 20 divided by 7, what is the remainder now? So can I say 30 divided by 7, remainder is minus 1. So my question is now minus 1 raised to 20. And I need to divide this by 7 and finding the remainder. But minus 1 raised to 20 is of course 1. So 1 divided by 7, remainder is 1. See, we simplified this complicated question in fractions of second. Right? Isn't that, guys? Yes. Okay. Where is your Glucon-D bottle? It's with you, na? Make sure, don't allow it to slip away. Okay, so let's look at this high power remainder question. Please do not forget to note down this point quickly. In the high power remainder questions, always try to get remainder 1 or minus 1. Correct? Try to get remainder 1 or minus 1. Yes, Nicole, beautiful bottle, huh? Where did you buy it from? Okay. So guys, this is the concept that we need to use. So let's apply it. So here 8 raised to 31 divided by 7. So what is 8 divided by 7? Remainder is 1. So now my question is 1 raised to 31 divided by 7. Answer will be 1. Same way, 6 raised to 20 divided by 7. What is the remainder? So 6 divided by 7. Can I say 6 is 1 less than multiple of 7? 7 ones are 7. Right. So here the remainder is minus 1. Minus 1 raised to 20 divided by 7. Again, remainder will be 1. Very quickly you can solve those questions. So let's take few more questions. So here you need to divide again by 7. So 4 raised to 30 divided by 7. Now guys, 4 raised to 30, I mean 4 divided by 7 will not give you remainder 1 or minus 1 directly. So think of some power of 4 which when you divide by 7 will leave remainder 1. Can I say 4 cube is 64 and 64 divided by 7 will leave remainder 1? So ultimately we are moving towards our goal of getting remainder 1. So how can I represent this 4 raised to 30 in the form of 4 raised to 3? Can I say it's 4 raised to 3 whole raised to 10? So now my question is 64 raised to 10 divided by 7. Now 64 divided by 7, remainder is 1, and 1 raised to any power, remainder is going to be 1. Same way, this one 4 raised to 30. This we have already solved. Okay, fine. So we don't need to take that. This is just repeated. Okay, few more question. So 5 raised to 18 divided by 7. Once again. So which power of 5 will give you remainder 1 or minus 1 when you divide by 7? So 18 sevens are 126. Okay, and 5 cube is 125. Try to get that close to any multiple of 7. So I know 5 cube is 125. Right. So I can represent this as 5 cube whole raised to 18. Now 5 cube is 125 and 125 divided by 7. So its remainder minus 1. So this will come out to be minus 1 remainder because 18 sevens are 126 and 5 cube is 125. So 5 cube is 1 behind some multiple of 7. That's what we can say. And minus 1 raised to even power, the remainder is going to be 1. So this is how you can quickly solve the questions. Right. Apart from that, I'll suggest that you remember certain theorems related to this remainders, because if the questions are asked and if you remember this question, you will spend just 30-40 seconds to get the answer, right? Most of the students will not solve this question because they don't remember these theorems. I'll suggest you that please try to note down right now. Don't mug it up straight away. But in the month of October, November, when you are in the final lap of your preparation, make sure that this concept is also there. In fact, if you are attending our daily live sessions, I'll make sure that I conduct the revision in the month of October, November, so that you do not miss any of the important concepts. In the month of October, November, we are just going to solve questions every day throughout the day. Okay. Fine. So formats a little theorem, and yeah, this is an extension of the same theorem. Let's look at this one first. So a raised to p minus a is completely divisible by p, where p is the prime number and a should be less than p. So that means 2 raised to 7 minus 2 divided by 7, remainder will be 0. It's completely divisible. So now can I say 2 raised to 7 by 7, remainder will be 2. Here we subtracted 2, so we got remainder 0. So here if we do not subtract 2, we should get remainder 2 now. So this is the point. So same way, if I say 5 raised to 7 divided by 7, remainder will be 5. If you want, you can check this way. Just check what is 5 raised to 7 divided by 7, you will get remainder as 5. Or if you want 12 raised to 13 divided by 13, remainder will be 12. Very beautiful, simple concept that some mathematician found out. But if I do it this way, 12 raised to 13 minus 12 divided by 13, so now it will be completely divisible, remainder will be 0. It's like we are subtracting 12 out of this. Yes guys, are you all with me? Show me a thumbs up quickly so that we can proceed the next part. So we are about to complete this remainder questions, in fact. Okay, so same way, there is a Wilson's theorem which is about factorial numbers. What about others? Varshini, Akash, and then Robin. Where is Robin? Okay, so Wilson's remainder theorem, it's about factorial number, please remember. So p minus 1 factorial divided by p, the remainder will always be p minus 1. So 5 minus 1 factorial divided by 5, remainder will be same p minus 1. So here what will be the remainder? 4. P minus 1 means 4. 7 minus 1 factorial divided by 7, that is 6 factorial divided by 7, remainder will be 6. 31 minus 1, that is 30 factorial divided by 31, remainder will be 30. You can check guys, you can check this thing. This is a very useful concept. And there's Euler numbers, Euler's remainder theorem, right? So a raised to phi of n divided by n, remainder is 1. So for example, what are the Euler numbers for 30? Everyone, what are the Euler numbers for 30? So we know it's 8. We had calculated that, if you remember, phi of 30 is equal to 30 into 1 minus 1 by a into 1 minus 1 by b, that is 3, and into 1 minus 1 by c, that is 5. If you solve this, it came out to be 30. So let me create a question based on this. Remember, a should be less than n and a and n should be co-prime, right? So if I take something like this, say 7 will be a prime number, very obvious thing. 7 raised to 16 divided by 30, remainder will be 1, guys. Why? Please understand, Euler numbers for 30 is 8. So can I write down this way? 7 raised to 8 divided by 30 is nothing but remainder 1, because this 8 is nothing but phi of 30. So 7 is less than 30, 7 and 30 are co-prime, so this will leave remainder 1. So even if I write 7 raised to 8 whole square divided by 30, of course the remainder will be 1 only. So this is how I applied Euler's remainder theorem in this question. Correct? Everyone, show me a thumbs up quickly. Yeah, one more hour and we are through with the complete number system. See, remainder is almost over. Then we'll practice some questions of remainder. So I'll give you 5 minutes time to practice the remainder questions. Okay, please be there. I'm going to give you 5 minutes time to practice remainder question. And then we'll discuss cyclicity, that is for last digit. Then we'll look at last two digits. In fact, we'll also revise those Vedic maths method, because for last two digits we'll require to apply those Vedic maths method. And then last part, factorial, binomial and algebraic concepts, which was the last part of number system. Yeah, Varshini, Robin, Nicole, Akash, great. There are a few more students, they are just listening, they're coming, they're going. It looks like that. I can see the live viewers are going up 15, down, and so on and so forth. You know, fine. But I'm sure all of you have decided that you want to score 90 plus percentile. And I'm sure very soon this ambition would go to 95 plus percentile, and then we'll try to take it to 99 plus percentile, right? So be with me. Okay, now there are certain special cases, as I had mentioned. Let's quickly understand through an example. Any number raised to any power divided by twice of that number will either leave remainder the number itself or 0. The condition is whether the number is even or the number is odd. So 5 raised to 18 divided by 10, remainder is 5, because see, 10 is double of 5 and 5 is odd, so remainder will be 5. 6 raised to 17, 6 raised to 17 divided by 12. See, this power can be anything, whether it's 17 or 70 or 50, doesn't matter here. There is no role of power. 6 raised to some power divided by 12, remainder will be 0, because 12 is double of 6 and 6 is an even number, right? Yeah, so I'm sure you have understood this concept. Now guys, once again, let me quickly tell you about my special classes. So if you haven't downloaded the Unacademy app, please do it right away, so you can attend my sessions, daily live sessions over here on YouTube, as well as you can attend on Unacademy platform. For that you should have downloaded just the mobile app. You don't need to take any subscription for that, and I'm conducting plenty of special classes over there, revision classes and conceptual classes and PYQs, that is previous year question classes. So you can attend that if you have downloaded this app, and you can follow me by my name, which is Ronak Shah. Make sure there is no space over here, right? And in case if you don't find me by this name, search in the all educators, search me by this name. Once you have searched by this name, click on all educators and you will surely find me. Follow me. Do not forget to rate me, so that my sessions will be visible upward. Okay, and tomorrow I'm going to conduct, so tomorrow it's Sunday, so I'm going to conduct a marathon session on permutation, combination and probability. Complete permutation, combination, probability in 3 hours. Like, this is a marathon session on numbers, same way it will be a marathon session on permutation, combination, probability. So even if you don't know anything about PNC, or if you are scared of PNC, come and join hands with me. I'll take care of that fear. Okay, so guys, some really easy question. Find the remainder when the following numbers are divided by 8. So of course 514 divided by 8. What is the remainder when 514 is divided by 8? So you know 512 is some power of 2, so it's completely divisible by 8. So 514 divided by 8, remainder is 2. So what is 2 square? 2 square is 4, so remainder is 4 over here. Same way 1009 divided by 8, remainder is 1. 1001 divided by 8, remainder is of course 2 more than the this one, that is 3. So 1 into 3, final remainder is 3. 2 raised to 12 divided by 8. So please understand, remainder will be 0, because 2 cube itself is 8. So any further power of 2, that number will always be completely divisible by 8. You know, 2 raised to 12 divided by 8. 8 is nothing but 2 cube. So this is going to be completely divisible, and that's why the remainder is 0. Same way, this 3 raised to 40 divided by 8. So you can interpret this way: 3 square whole raised to 20 divided by 8. So 3 square is 9. 9 divided by 8 is 1. 1 raised to any power, final remainder is 1. And same way you can quickly solve this question. It's not that difficult. So again, 7 divided by 8, remainder is -1. Let me just write it here. So 5 raised to 10 can be written as 5 square whole raised to 5 into 7 raised to 8 as it is divided by 8. Now what is 5 square? 25. 25 divided by 8, remainder is 1. What is 7 divided by 8? Remainder is -1. -1 raised to even power. So of course it's going to be 1, and this is also 1. So final remainder is 1. Yeah. See, I've solved all the questions for you. Okay. So this is how we need to solve this set of questions. Okay. So let me give you a few more questions. Everyone, please try for this question before we go ahead with the next set of concepts. You need to solve this question. Try for this one, then this one, and let me give you a few more questions. So It should be 4 raised to, no, not 4. Let's take something else. Let me take 13 raised to 91 divide by 7. Um, 11 raised to 91 divided by 7. So tell me the remainder. So this is the third question that you need to solve, and there is one more question which let me give you is something like this. Okay, so that question is 12 raised to 12 raised to, let's find out something. 60 divide by 7, find the remainder. So everyone, now I have given you 4 questions. You will take 5 minutes time. Okay, if you want, you can take a small break of 2 minutes here. The session will continue. I'll join you in about 5 minutes. So make sure that you have solved this 4 questions. It's for you. Show me a thumbs up quickly that you are with me and you are solving this question. Show me a thumbs up quickly. Yes, so please solve this question. I'll be back. Yeah, hi everyone. Yes, so welcome back everyone. Yeah, hi, Jagu Singh. We are very much here. So this is a marathon session on number system on daily life of Unacademy CAT4MBA, and we are completing the number system for CAT 2020 and other MBA entrance exams. So this session was started, sometimes back about 1.5 hour back. Right. Yes, Jagu, are you there? Yes, great. Good to see you. And what about others? Everyone, show me a thumbs up. Have you solved these questions? The 4 questions that I had given. Quickly type your answers in the chat box before we proceed with the next concept. Quickly type the answer in the chat box. What's the answer for first question? 13 raised to 91 divided by 9. Of course, 13 divided by 9, the remainder is 4. So now my question is 4 raised to 91 divided by 9. Yeah, hi. What about others? Akash, Nicole, Robin. There were a few more. Right. Okay. So everyone, please settle down quickly. So now this question is simple. Identify the power of 4. That will leave remainder 1 when you divide by 9. So 4 cube is 64. 64 divided by 9. Remainder is 1. Isn't that? Yes. So we'll write this one as. But then see, this power can't be directly represented as a multiple of 3. So we'll have to do it this way. 4 cube whole raised to 30 into 4 raised to 1 divide by 9. Now 4 cube is 64. 64 divided by 9, remainder is 1. So 1 raised to 30, it's going to be 1. So this part remainder is 1. Okay, and we are left with just this 4. So 1 into 4, it's 4. So final remainder is 4. Yes. Okay, great. So same way, 12 raised to 40 divide by 25. Find the remainder. Okay, 12 raised to 40 divide by 25. How will you find the remainder over here in this case? So 12 divided by 25, of course we can't do it directly. In fact, now if you think about different powers of 12, so 12 square is 144, and 144 divided by 25, again it's not leaving remainder 1 or minus 1. That means we'll have to apply some other concept. In fact, can we apply the Euler's remainder theorem over here? Euler's remainder theorem. What does Euler's remainder theorem says? Okay, any number, any number a raised to phi of n divide by n, remainder will be 1. Now you should know what are the coprimes for 25, because n is 25. So what are the coprimes for 25? So guys, if you check coprime for 25 or phi of 25, it's 20, right? I have just shown. So in case if you have just joined, guys, what you can do is you can just revisit the video after the session so that you will understand this part in case if you are not clear. So this question can be written as 12 raised to 20 whole raised to 2 divided by 25, and this part satisfies the Euler's remainder theorem, so it's going to be 1. So final remainder will be 1 for this one. Now what about this question? Let me just write in a different way so that there is no confusion. Correct. 11 raised to 91 divided by 7. What is 11 divided by 7? Remainder is 4. So my question is 4 raised to 91 divided by 7. And it can be solved exactly in the same way. 4 cube is 64, right? And 64 divided by 7, remainder is going to be 1. So ultimately, if you check this thing, remainder is going to be 4. And what about this one? So again, we can apply Euler's remainder theorem, because phi of 7 is a prime number. Guys, please remember, for any prime number, the number of coprimes will always be 1 less than that. So how many numbers less than 7 are coprime to 7? 6 numbers, right? How many numbers less than 11 are coprime to 11? 10 numbers, and so on and so forth. So here I can write it 12 raised to 6 whole raised to 10 divided by 7, and this satisfies Euler's theorem, so remainder will be 1. Yep. So yeah, Jagu, let me tell you. So this marathon is about of 3 hours. So 2 to 5. In fact, we'll try to complete that by 4:45. So we have 1 more hour, and in this next 1 hour, we are going to discuss last digit, last two digits, and factorial. These are the concepts we are going to discuss. Okay, fine. So let's look at this last digit concept, which is also called cyclicity or power cycle, whatever you call it. So let's quickly understand the pattern in last digit. So if I take 2, 2 raised to 1, the last digit is 2, 2 raised to 2, last digit is 4, 2 raised to 3, last digit is 8, 2 raised to 4, 16, so last digit is 6. So we are just looking at the last digit of all these numbers. Same way, 2 raised to 5, 32, so last digit is 2, 2 raised to 6, again 64, so last digit is 4. So from here you will see repetition in the last digit, right? And since after every fourth power of 2, the pattern in the last digit is getting repeated, you can say it has cyclicity of 4. In fact, the same thing can also be represented pictorially in this way. So let me show you. We can make a cycle. It follows a cyclic pattern. So we can make a power cycle. 2 raised to 1, last digit is 2, 2 raised to 2, last digit is 4, then 2 raised to power 3, so 8, and 2 raised to power 4, so it's 6 again. 2 raised to 5 will again have the same last digit, 2 raised to 6 will have 4, 2 raised to 7, and so on and so forth. It will keep going on, right? This will keep going on. So now if I ask you what is the last digit of 2 raised to 85, so just check this power. Can I say it's one more than multiple of 4? So all the powers which are multiple of 4 will end over here. So can I say 2 raised to 84 will come over here? So 2 raised to 85 should be over here. So what will be the last digit? It's 2. So the last digit of this number is 2. Correct? Same way, you can observe the pattern for all other digits, that is 3, 4, 5, 6, 7 and all. So this is what I have prepared over here. So the complete power cycle for all the digits have been prepared. In fact, as I mentioned, the lecture notes will be shared after the session. If you have subscribed to our channel, so quickly press that subscribe button. And yes, do not forget to like this video. Press the like button as well if you are liking this session, and press the bell icon as well. This is Unacademy CAT4MBA channel, where we go daily live 8 to 10 hours, and you can prepare for your CAT completely free. It's Unacademy. Okay. Right, so cyclicity of 3 is also 4, cyclicity of 4 is of 2, and so on and so forth. So please remember these digits 2, 3, 7, 8, they have cyclicity of 4. Then digits 4 and 9 have cyclicity of 2, and digits 0, 1, 5, 6 have cyclicity of 1. Now what does it mean by cyclicity of 1? So if any number ends with any of this digit, that is 0, 1, 5, 6, the last digit of that number will remain same. So for example, 56 raised to 75, what is the last digit? Without thinking, you can straight away say 6. Or 45 raised to 45, what is the last digit? It has to be 5. Or 31 raised to 32, what is the last digit? It has to be 1. Are you getting this point? Everyone show me a thumbs up if you all are with me, if you have understood the cyclicity, so that I can quickly show you the questions once again. Right, okay, so here comes the questions for you. Everyone, type the answer in the chat box without using pen and paper. That would be superb. If you can do it without using pen and paper, fantastic. Straight away type the answer in the chat box. 2 raised to 91, so 2 raised to 96 will have last digit as 4, not 4. What will be the last digit of 2 raised to 96? 6. You know, this 2 raised to 4 last digit is 6. So 2 raised to 96 will have last digit 6, 2 raised to 97. Can I say last digit will be 2 again? Yes, same way, tell me the last digit for this one, as well as this one, as well as this one. Quickly, very fast. Type your answer in the chat box. I'm waiting. So 3 raised to 78, 3 raised to 76 will end at the fourth power. See, let me show you once again over here in case if there is any confusion. 3 raised to 1, 3. 3 raised to 2, 9. 3 raised to 3, 27. So last digit is 7. And 3 raised to 4, 81. So last digit is 1. Again 3 raised to 5 and all will come over here. So of course 3 raised to 76 will come over here. 3 raised to 77 will come over here. And 3 raised to 78 will come over here. So last digit has to be 9. Great. Yes, Varshini, that's precisely correct. 2947. So this will be same way 4, because 4 is cyclicity of just 2. So odd power, so same 4 last digit, even power last digit will be 6. Same way here last digit will be 7. So you quickly revise this concept so that you can answer these questions pretty fast. Do it. Same way you can solve this question. If you want, you can take a screenshot and solve it afterwards, right? So all of these are same questions. Now let's quickly understand the concept of last 2 digits. Everyone, let's understand these last 2 digit concepts. Okay, so for that, first of all, we need to understand this base 50 method for squares. It is used to find out square of 26 to 75, and then we'll understand base 100 method for squares. And apart from that, you need to remember squares of the number from 1 to 25. These are prerequisite for understanding the concept of last 2 digits. Yes, okay, fine. So let's go ahead with this one. So base 50 method, if I want to find out square of this number in the any number in this range, suppose 42 or say 61 or say 48, all these numbers, you can apply this method, base 50 method. So let's look at each of this one by one, everyone. So answer will be in 2 parts. We are using Vedic math, so answer will be in 2 parts. This is the left part of my answer, this is the right part of my answer. In fact, remember, in the right part you must have exactly 2 digits. If you get more than 2 digit result, you will carry over the extra digit to the left part. If you get less than 2 digit result, you will insert a 0 to fulfill that 2 digit requirement. Are you all clear with me, guys? Once again, show me a thumbs up, please. So I'll understand that all of you are with me. All those who are present watching me right now on daily live of Unacademy CAT4MBA, show me a thumbs up. Yeah, and make sure that you have pressed the like button. I think none of you have pressed the like button. So guys, first of all, press the like button quickly. I want to see plenty of likes, and please share it with your friends as well after the session. Please make it viral. Okay. Fine. So now to find out square of this number, compare this number with the base, which is 50. So this number is 4 more than 50. So right part will be 4 square and left part will be 25 plus 4. So जितना नंबर आपका 50 से ज्यादा है उसका स्क्वायर करके आपने राइट पार्ट में लिखा, और जितना ज्यादा है उतना आपने 25 में ऐड कर दिया. सो दिस 25 will remain common all the time. It will be constant. Okay. So remember that thing. So 25 plus 4, 29, and 4 square is 16. So this is the square, 2916. Since 4 square is 16, we straight away got 2 digit result. So that's why we don't need to do anything additional. Yeah, I didn't see any like, guys. Can you please press the like button for me? You can do this much, right? Okay. So once again, 42 square. So 42 is 8 less than 50. So right part will be 8 square. C नंबर जितना आपका 50 से कम है या ज्यादा है उसका स्क्वायर करके राइट पार्ट में लिखना है, एंड दैट शुड बी ओनली 2 डिजिट रिजल्ट इन द राइट पार्ट. ओके फाइन. एंड लेफ्ट पार्ट में क्या करोगे? सो अभी नंबर कम है तो उतना 25 से सब्ट्रैक्ट कर दो. सो लेफ्ट पार्ट विल बी 25 minus 8. Are we clear with this? Okay, so what is 25 minus 8? It's 17. What is 8 square? It's 64. So 1764 is the square. ठीक है. Same way 61 square. So what is 61 square? So compare it with the base 50. It's 11 more. So right part should be 11 square. Left part 25 plus 11. Yes. Okay. So 25 plus 11, 36. 11 square 121. So again this digit has to be carried over because we need to keep only 2 digits. So this extra digit will be carried over to the left part. So 36 plus 1, it's 37, 21. Same way 48 square. So it's 2 less than 50. So write 2 square, and left part 25 minus 2. What is 25 minus 2? 23. What is 2 square? 4. So how can we make it a 2 digit number? By writing it 04. So this is the square. Are we clear with this, everyone? Right. So let's look at base 100 method. Once again, let me take 2-3 different examples. So suppose I want to find out square of this number 106. Again, answer in 2 parts. Right part, left part. That should be exactly 2 digit result in the right part. Remember that rule applies over here also. So now compare the number with the base. It's 6 more than 100, so write down 6 square, and left part will be 106 plus 6. नंबर जितना ज्यादा है या कम है उतना नंबर में ही ऐड या सब्ट्रैक्ट कर देना है. दिस इज द लेफ्ट पार्ट. Okay, so 106 plus 6, 112, 6 square, 36. Same way, if I want to find out 88 square, so it's 12 less than 100, so 12 square. Left part, 88 minus 12. So what is 88 minus 12? 76. 12 square, 144. Keep 44 here, 1 carried over, 7744. Yes, everyone? Perfect. Okay, so one more number. Suppose I want to find out square of 98. So 2 less than 100, so 2 square, and left part 98 minus 2, that is 96, and again this will be 0, 4. Yes? Okay, now quickly tell me the last 2 digits of this number. Everyone, now you need to tell me the last 2 digits of this number. Last 2 digits. Only. You don't need to calculate complete square. Can you tell me what will be the last 2 digits of this number? Everyone, just last 2 digits. So compare this number with the base. It's 7 more than 50. We'll apply base 50 method. So can I say 7 more? So this has to be 49. Right. Same way, keep writing in the chat box. So whatever question I ask you, you need to tell me the last 2 digits of that number and enter it in the chat box quickly. What about 69 square? What will be the last 2 digits? Write it in the chat box, everyone. 69 square, last 2 digits. Isn't this correct? Because 69 is 19 more than 50. So we'll write right side will be 19 square, 361. We'll keep 3 over there. We'll keep 61 over there, and 3 will be carried over. So ultimately we need to look at the last 2 digits only, right? Okay, what about this number 36? What will be the last 2 digits of this number 36? Quickly, last 2 digits of 36 square. Yes, can I say it's 96? Because 36 is 14 less than 50. So 14 square will come in the right part. So 14 square is 196. So keep 96 over there. So last 2 digits will be 96, right? What about this one, 92 square? What will be the last 2 digits in the 92 square? Same way, what about 71 square? What will be the last 2 digits in 71 square? So 92, it's 8 less than 100. We'll apply base 100 method. So last 2 digits will be 64. 71, 21 more than 50. So we need to find out 21 square. So last 2 digits will be 41. 21 square is 441. Correct. Yup. So now this is how you will use this base 100 and base 50 method while finding last 2 digits. So let's understand the approach to find out last 2 digits of any number. So first we'll check whether the number is ending with 1. So the approach for finding last 2 digits for such numbers where the last digit is 1 is different. Then the second will check whether it's ending with 5. So approach will be different if it's ending with 5. In fact, these two are very simple. These two are very simple. The easiest among all. Then we'll look at whether the number is ending with 379. So if the number is an odd number ending in either 3 or 7 or 9, the approach will be different. And if it's an even number, that means last digit is 0, 2, 4, 6, 8, then the approach will be different. So we need to discuss these 4 approaches in next 5 minutes. Okay, now before that, let me quickly tell you the advantages of subscription. You can take Unacademy subscription, quickly download the mobile app and go for the subscription. In that you will get test series, you will get access to leaderboard, you will be able to interact with me on personal level. So these are some of the advantages that you derive. Apart from that, there are a few more, right? And for that you need to download the app, and after that select your goal as CAT and click on the plus subscription. And when you click on the get subscription, you will see this plans 1 month, 3, 6, 12, 24. Go for either 12 or 24 because the monthly cost is pretty less. And when you go for that, do not forget to use my referral code, which is SHAH10. Yes, this is SHAH10. Share it with your friends also in case if they're planning to go for this, right? So coming back to finding last 2 digits. Okay, the first approach is the first case is if the number is ending with 1. So for such questions, Just a moment, huh? Find the last two digits of the number of this one. What you need to do is, let me straight away explain before that. If you want, you can note down this point. The last digit will always be 1, and the second last digit can be obtained by multiplying the tens digit of the base with the units digit of the power. So let's understand with an example. What is the last two digits of this number? So last digit is as usual 1, and the second last digit, multiply this tens digit of the base with units digit of the power. 3 4s are 12, so take 2 over here. 12 का 2 जो है वो यहाँ पे लिख देना है. Same way, what will be the last two digits of this number? Of course, last digit is 1. Multiply 5 with 6, it's 30. So 30 का 0 यहाँ पे रख दोगे. Same way, last digit over here will be 1. Second last digit 4 with 3. 4 3s are 12. तो 12 का 2 वापस यहाँ पे रख दोगे. तो again it will come out to be 21. Guys, have you all understood this point? Is there any confusion? Please let me know if there is any confusion. Please let me know quickly so that I can explain that once again if required. Okay? Yeah. Fine. So now let's understand how to find out last two digits of the number which end with digit 5. So in that, you need to remember that last two digits will be 25 or 75. Now on which will it depend? So remember this thing, last two digits will be either 25 or 75. If this tens digit of the base multiplied with the units digit of power, if that produces even result, then last two digits will be 25. If it produces odd result, then last two digits will be 75. Okay. So if the result is even, okay, then last two digits will be 25, else it will be 75. So here, can I say 3 3s are 9? So it's an odd number, so last two digits will be 75 straight away. 6 7s are 42, so it's even result, so last two digits will be 25. Then this 5 3s are 15, tens digit with the units digit of the base. So 5 3s are 15. Okay, so odd result, so this will be, last two digits will be again 75. Yes, everyone? Okay, fine. So let's look at how to calculate last two digits of numbers ending in 3, 7 and 9. So the approach is, try to get 1 at the end. Once you have got 1, then you can apply this rule, right? So let's take an example. 43 raised to 24. Now I know 3 raised to 4 is 1. Okay, so if I raise this number to the 4th power, it will produce last digit 1. Once we have got a number with last digit 1, we can easily find out last two digits of that number using that first method. Yes or no? So we need to raise this one to the 4th power. So now my question is 43 raised to 4 whole raised to 6, because we need to maintain this power 24, right? Now what is 43 raised to 4? Let's understand. So 43 raised to 4 is 43 square whole square. Now what is 43 square, everyone? So you know what will be the last two digits of this square. So can I say 43 is 7 less than 50? So last two digits will be 7 square, that is 49. And now I need to find out 49 squares last two digits. So 49 is 1 less than 50. So last two digits will be 1 square, that is 0 1. So actually my question became this way. 0 1 raised to 6. Of course the last digit will be 1 and the second last digit will be 0. So these are the last two digits of the number. Have you all understood this? Show me a thumbs up if you all understood this part. Show me a thumbs up quickly. Right, so let's go to the next part then. Great. So all of you understood this. So let's try for this question. Now look at the cyclicity of 9. Can I say 9 square will produce a last digit as 1? Correct. So if I raise this number to the second power, it will produce last digit 1. So I'll write this as 89 square whole raised to 71. Now what will be the last two digits of this square? Can you please write it in the chat box? What will be the last two digits in the 89 square? Quickly type it in the chat box. Yes, that will be 21, because 89 is 11 less than 100. So 11 square is 121. So last two digits will be 21. So now my question is finding last two digits of this one, 21 raised to 71. Of course, the last digit has to be 1 and the second last digit will be 2 multiplied with 1. Right? So 2 ones are 2. So we'll put 21 over here. These are the last two digits of this number, correct? So you can solve any question using this method. Even over here, what you need to do is 57. 7, if you raise 7 to the 4th power, it will produce last digit as 1. So how can we represent this one? So it will be 57 raised to 4 whole raised to 14 into 57 raised to 1. Now 57 raised to 4 can be understood as 57 square whole square. So this is 7 more than 50. So last two digits will be 49 and then square. So what are the last two digits of 49? It will be 0, 1. So now my question is 0, 1 raised to 14 into 57. Of course, this is going to be 1 into 57. So last two digits of this number will be 57. You can always verify it this way. Okay, this last digit is 7. Now 7 raised to 77. What will be the last digit? Can I say last digit will of course be 7? Everyone? Yes, so we have got that answer. That means chances of our answer being correct are very high, right? Okay, great. Fine guys, so once again, some of the benefits of Plus subscription, you know about this code and discounts, so keep using this, right? Now we want to find out last two digits of the number which ends with even digit or you can say last two digits of any even number. Okay, so the approach to find out this last two digits of any even number is you will have to segregate powers of 2. You will have to segregate 2 and make the number odd. So from any number, if we segregate 2s, then we get the odd number. Okay, so जैसे गन्ने में से जूस निकाल देते हो तो क्या बचता है? उसका वही बचता है ना, राइट? सो वैसे ही यहाँ पे 2 हटा दो तो वो ऑड नंबर बचेगा. ऑड नंबर बचा तो आप फिर तो आपको पता ही है ऑड नंबर का लास्ट डिजिट कैसे फाइंड करना है, लास्ट टू डिजिट कैसे फाइंड करना है. बट बिफोर दैट वी नीड टू क्विकली अंडरस्टैंड दिस मैजिकल नंबर 76 एंड आई एम श्योर यू विल बी सरप्राइज्ड लुकिंग एट दिस रिजल्ट. सो इफ यू टेक एनी पावर ऑफ 2 and if you multiply the last two digits of that power of 2 with 76, the result will be the same except 2 raised to 1. 2 raised to 1 is an exception. Put it aside. So for example, 2 raised to 2 is 4. So let me call 4 as 04. So these are the two digits. Multiply with 76. The result will have last two digits as 04. Same way 8 can be considered as 08. 8 is nothing but 2 cube. So let's consider that as 08. 08 into 76 will produce 08 at the end. 16 into 76, last two digits 16 and so on and so forth. So 1024, 2 raised to 10 is 1024, last two digits are 24. So 24 into 76, it will produce 24 as the last two digits. And we are going to use this one while finding the last two digits of even numbers, right? So let's understand that. But before that, you need to understand this point also, that 2 raised to 20 is 76. See, please understand 2 raised to 10 will have last two digits as 24. This we have understood. Now 2 raised to 20 will be 76. Why? Very simple to understand. 2 raised to 20 is nothing but 2 raised to 10 into 2 raised to 10. So 2 raised to 10 has last two digits as 24. So 24 into 24, it's 576. So last two digits will be 76. Are we clear with this? Right. So that's why 2 raised to 20 is 76. Again, 2 raised to 40 will be 76. So you can also think it this way. 2 raised to 10, 24. 2 raised to 20, 76. Again, 2 raised to 30, the last two digits will be 24. 2 raised to 40, again it will be 76. 2 raised to 50, it will be again 24 and so on and so forth. So in general, I can write it this way. 2 raised to 10 raised to odd power, last two digits will be 24. 2 raised to 10 whole raised to even power, last two digits will be 76. Correct? Now let me tell you how are we going to use this thing. So for example, if I ask you this question, 2 raised to 46, what are the last two digits? So can I say 2 raised to 46 is nothing but 2 raised to 20 whole raised to 2 into 2 raised to 6. Now 2 raised to 20 raised to even power, definitely, in fact, you can also think it this way, 2 raised to 10 raised to 4. So into 2 raised to 6. So this is also 40, and 2 raised to 10 whole raised to even power. So this is going to produce 76. 2 raised to 6 is 64. So 76 into 64, of course, it's going to produce 64 as a result, as part of this magical number 76. Guys, have you all understood up to this point? Show me a thumbs up quickly. Once you have understood this, you can show me a thumbs up, right? Fine. Okay. Yes. So for numbers ending with 2, 4, 6, 8, separate 2's and then apply method discussed in case 2 and 3, right? So let's quickly look at the question so we'll understand that better. For example, first question, 32 raised to 34. Now 32 itself is 2 raised to 5. So this is a slightly different question, whole raised to 34. And this is 2 raised to 170, which can be thought as 2 raised to 10, whole raised to 17, odd power. So last two digits have to be 24. 2 raised to 10, whole raised to odd, last two digits 24. Same way, 82 raised to 34. So this can be interpreted as 2 into 41 whole raised to 34. So now my question is 2 raised to 34 into 41 raised to 34. Now 2 raised to 34 is again 2 raised to 10 whole raised to 3 into 2 raised to 4 into this 41 raised to 34. Can I say last digit will be 1 and second last digit will be 4 into 4, 16. So 6 over here. Again, this is 2 raised to 10 whole raised to what? So this will be 24 into 16 into 61. So you will have to first multiply. If you want, you can multiply it this way. 24 into 16. Find out the last two digits. So multiply this to 4 6 are 24. Put 4 over here. 2 is your carry. Then do a crisscross. So 2 6 are 12 plus 4 1s are 4, 16 plus 2 18. 12 plus 4 16 plus 2 just carry 18. So it will be 84. So this result will produce last two digits as 84 multiplied with 61. So again 84 into 61. Same way, 4 1s are 4, crisscross, 8 1s are 8, 4 6 are 24. 8 plus 24 32. So put 2 over here, last two digits will be 24. So final last two digits of this number will be 24. So the last two digits of this number is going to be 24. This is your answer. Yes, so this is how you can quickly find out last two digits of any even number, right guys? So let's quickly understand what all we have discussed as part of this marathon session on number system, on daily life of CAT for MBA. Okay, so we started with number line, then we discussed modulus, then greatest integer value, least integer value, then factors and multiples, then HCF, LCM, prime numbers, composite numbers, prime factorization, how to find out number of factors, particularly number of factors ending with 10 or number of factors divisible by 6 and all those CAT question. Then we discussed the concept of remainders, right? So different remainder theorems. Then we discussed power cycle, right? So cyclicity, that is to find out last digit. And now we have finished discussing how to find out last two digits. So this is what all you have learned, right? It's like a workshop, right? A free workshop. Everyone, right? So एक like button दबाना तो बनता है. So please press the like button in case if you haven't liked this session yet. In case if you haven't pressed the like button yet, of course I'm sure you are enjoying the session and that's why you are with me. So this is how you can also find out last two digits of this number, guys. So in simple words, for number ending with 1, this is what we do. Number ending with 5, it will always be 25 or 75. The case 3 379. So we will try to get last digit as 1 and then even numbers, so separate 2's, and this is the summary of last two digits method, right? So now guys, we will understand the concept of factorial. So this is concept of factorial. So in factorial, we need to find out power of prime number in the given factorial number. So how do we do it? So guys, if I ask you that how many 2's are there in 10 factorial? So of course, first of all, 10 factorial is what? 10 into 9 into 8 into 7 up to 1, right? So how many 2's do you find in this number? So can I say there is 1 2 over here, there are 3 2's over here, there is 1 2 over here, there are 2 2's over here and 1 more 2 over here. We forgot 3 over here, right? So what are the total number of 2's? 1 plus 3 plus 1 plus 2 plus 1. So it will come out to be 8. So number of 2's are 8. Same way, what are the number of 3's? So can I say there is 1 3, there are 2 3's over here, then there is 1 3 over here, and there is 1 3 over here. So power of 3 is 4. But if I ask you what are the number of 2's in 50 factorial, or what is the power of 3 in 50 factorial, how can we do it? So this method won't work. So for that we can use a simple approach, that if you want to find out power of any prime number in the given factorial number, this is what we need to do. So what is the power of 2 in 40 factorial? What is the power of 2 in 40 factorial? So this is what you want to find out. So divide 40 by 2 raised to 1, then 40 by 2 raised to 2, then 40 by 2 raised to 3, and so on and so forth, and write down the quotient, and then write down the quotient. So 40 divided by 2 raised to 1, what is the quotient? It's 20. Same way 40 divided by 2 raised to 2, so what is the quotient? It's 10. 40 divided by 2 raised to 3, what is the quotient? It's 5. 2 raised to 4, 16. 40 divided by 16, the quotient is 2. 16 2s are 32. And 40 divided by 2 raised to 5, that is 32. So quotient will be 1. I don't need to try further, because 40 divided by 64, the quotient will be 0. Or 40 divided by 128, again the quotient will be 0. So that's why this is what we need to get, and just add them. So you will get power of 2 in 40 factorial. So power of 2 will be 20 plus 10, 30 plus 8. So it will be 2 raised to 38. Yes. So this is how you can find out power of any prime number in the given factorial number. Please remember, you can't find out power of composite number using this method. You can find out only power of prime number, that is 2, 3, 5, 7, 11, 13, and so on and so forth. You can use this approach. Now, if I ask you what is power of 4 in this prime number, what is the power of 4? So can I say 4 is nothing but 2 square? 4 is nothing but 2 square, right? So if 2 raised to 38 is there, so can I say 4 raised to 19 should be there? So what is the power of 4 in this factorial, this 40 factorial? It's 19, right? So this will come out to be 38, and this will come out to be 19. So this is how you can find out power of any composite number in the given factorial number, right? So apply that concept over here, and you can find out the power. Can you quickly tell me what is the power of 2 in 50 factorial and 100 factorial? Type your answer in the chat box. Everyone, quickly type your answer in the chat box. Yep. So what is the power of 2 in 50 factorial? So divide 50 by 2. So the quotients, let's quickly write down quotient. 50 divided by 2, it's 25. 50 divided by 4, it's 12. Quotient is 12. Then 50 divided by 8, quotient is 6. 50 divided by 16, quotient is 3. 50 divided by 32, quotient is 1. Right? And 50 divided by 64, not needed. So just add them. This will come out to be what? 47. Right? So power of 2 in 50 factorial is 47. Yes. Same way, tell me for 100 factorial quickly. What is the power of 2 in 100 factorial? So write down the quotients. 100 divided by 2, 50. 100 divided by 4, 25. 100 divided by 8, 12. 12 8s are 96. 100 divided by 16, 6. 100 divided by 32, 3. 100 divided by 64, 1. And 100 divided by 128, the quotient will become 0. So this will come out to be 97, right? So power of 2 is 97. Yes. Okay. So can you quickly tell me what is power of 4 over here? What is the power of 4? If 2 is 47, so what will be the power of 4? Same way, what is the power of 4 in this number? Guys, type it in the chat box. "23", that's correct. So power of 4 is 23, because power of 2 is 47. So what is half of 47? 23.5. So we'll have to take integer number 23. Same way here, it's 2 raised to 97. So what is half of 97? 48.5. So we'll take 48. Correct. So these are the powers of 4. In fact, can you tell me what is power of 3 over here in these numbers? So write down the quotients. 50 divided by 3, 16. 50 divided by 9, 5. 50 divided by 27, 1. That's it. So 3 raised to कितना आएगा? 22. Correct? Same way, if you check over here, what are the quotients? You can quickly calculate this power, right? So it will come out to be, the quotients will come out to be, if 100 divided by 3, 33. 100 divided by 9, 11. 100 divided by 27, so 3. 100 divided by 81, 1, and so on and so forth. So this will come out to be 48, right? 3 raised to 48. Correct, everyone? Yeah. So if I ask you, what are the power of 6 in these numbers? Can you tell me what are the power of 6? So you understand 6 is nothing but 2 into 3. In 50 factorial, we have 2 raised to 47 and we have 3 raised to 22. So how many pairs of 2 and 3 can be made? Of course, 22 pairs. So power of 6 will be 22. Same way in 100 factorial, power of 2 is 97, but power of 3 is just 48. Okay, of course there are some other numbers, but we are interested only in this prime numbers. So what are the pairs I can make? Of course 48. So 6 raised to 48. So power of 6 is 48 and 22. It's equivalent to the higher prime numbers, right? So if you want to find out next time, say power of 6 in 70 factorial, then you really don't need to calculate power of 2. You just need to find out power of 3, and that will be the power of 6, because you will have plenty of 2s, but you have limited 3s, right? So that's how you solve such questions. Number of zeros at the end, so you need to just check what are the pairs of 2 and 5 in that prime number. Of course 2s will be plenty, so what will be the number of 5s in that? So for example, if I ask you how many zeros will be there at the end of 100 factorial, just find out power of 5, and that many pair of 2 and 5 you can make. So if you calculate power of 5, it's 24, so there will be 24 zeros. Right, everyone? So this is how we can quickly answer this question. So these are a few questions. Now just to quickly give you an idea about binomial expansion. So binomial, see, algebraic expression can be monomial, binomial or polynomial. Monomial means an algebraic expression with just one term. You know, you have heard of monorail. So monorail runs on one track. So mono is a prefix which indicates one. So same way bi indicates two and poly indicates many. So binomial means an algebraic expression with two terms. So here we have two terms and we are raising it to the nth power, and this is the rule by which it can be expanded. Okay, remember that NCR is equal to n factorial upon n minus r factorial into r factorial. So if I ask you to find out 3C2, this is how you do it: 3 factorial upon 3 minus 2 factorial into 2 factorial. If you calculate, it will come out to be 3. In fact, 3C1 will also be 3. Remember, NC0 and NCN both are 1. So we are going to discuss these things during our permutation combination sessions. Once again, just for your information, tomorrow we are going to conduct a permutation combination marathon. I am going to conduct that not over here on YouTube but on Unacademy platform. So quickly download the mobile app and follow me on Unacademy platform by the name Ronak Shah, so that you can attend my session. Okay, so guys, coming back to this one. Right, where can we use? So all those formula, a plus b whole square or a plus b whole cube and so on and so forth, they have come using this rule. Now what does this rule say? So observe the power of variables. So in the first term you have full n power of x, and it goes and it becomes 0 in the last term. So you are reducing 1 power of x and you are increasing 1 power of y. So let me do it over here. First, in the first term you will have 2 power of a. In the second term there will be 1 less power of a and 1 power of b, and in the third term no power of a and 2 power of b. So 2, 1 and 0 power, b ki power 0, 1 and 2. Now what are the coefficients? So here you will have 2c2, you will have 2c1, and this will be this will be 2c0, then this is 2c1 and this is 2c2. So 2c0 is 1, 2c1 is 2 and 2c2 is 1. So that's why this formula came a square plus 2ab plus b square. And same way a plus b whole cube. So first let's write down the variable a cube plus a square b plus ab square plus b cube. Now let's write down the coefficient 3c0, 3c1, 3c2 and 3c3. Right, so 3c0 is 1, so first term will be a cube, then this will be 3a square b, and this will be 3ab square, and this will be b cube. So this is how you can apply this concept, right? Have you all understood this binomial expansion? Yeah, so there are plenty of questions. So in subsequent sessions, in subsequent marathon on numbers, I'll be taking some questions on binomial expansion also. So over there we'll discuss this in detail. For timing, let me quickly tell you algebraic formulae that you need to remember. So these are the list of formulae. Of course, a plus b whole square minus b whole square, a plus b whole cube minus whole cube, a square minus b square. Remember, a square plus b square can't be factorized. Same way this, remember, this can't be factorized. So in general, a raised to n plus b raised to n can be factorized only when n is odd. So if there is a plus sign and if this power is odd, only then you can factorize it. You can't factorize this one or this one. But a raised to n minus b raised to n, if there is a minus sign, you can always factorize it. So this is something that you had to remember. Okay, so write the first and last three terms in the expansion of this one. So guys, m plus 2 whole raised to 6. Okay, if I ask you to write the first three terms, can I say first term will be m raised to 6 into 2 raised to 0. Then second term m raised to 5 and 2 raised to 1. Third term m raised to 4 and 2 raised to 2. The last term will have m raised to 0. Let me just write here. The last term will have m raised to 0, 2 raised to 6. The second last term will have m raised to 1, 2 raised to 5. The third last term will have m raised to 2, 2 raised to 4. So these are the first three terms and these are the last three terms. But we are yet to put the coefficient. So this will be 6c0, 6c1, 6c2. Same way ulta shuru karte hain. Last one will be 6c6. This will be 6c5 and this will be 6c4. Right, so let's simplify this thing over here. So this is going to be 1. So first term will be m raised to 6. Second term 6c1 is 6, m raised to 5 into 2. So 6 into 2, 12. So this will be 12 m raised to 5. Third term will be 6c2. So let's solve 6c2 over here. So it's 6 factorial upon 6 minus 2 factorial into 2 factorial. If you solve this thing, 6 factorial is 720. Divide by 4 factorial, that is 24 into 2. So if you just solve this thing, it will come out to be 24, 3s are 72. So 30 divided by 2, it's 15. So it will be 15 m raised to 4. Of course, you will remember this over a period of time. And the last term, so if you look at last term, it's 2 raised to 6, that is 64. Okay, this is first, second and third term. Same way, this is the last term. Then second last term, 65, 6 into 2 raised to 5, 32, 32, 6 are, what is 32, 6 are? 192. So 192 m, and then 6c4 is 15 into 2 raised to 4, 16. It is 240. So this will be 240 m square. So this is how we can expand. Guys, have you all understood this? Can you show me a thumbs up one final time before we end the session? Quickly show me a thumbs up, everyone, if you are with me. So same way, there are a few more questions in which you just need to do the expansion and you can identify that what is the middle term, what is the coefficient of this term, and so on and so forth. Great. So I really appreciate your patience and watching it till the end. That itself shows that you are quite dedicated for your CAT preparation. And yes, what I can say is God bless you. You get the best of the results. And I see your picture in the newspaper among the list of 100 percentilers in 2020, right? Let's hope for the best. Okay, so guys, now before I wind up, would like to tell you one very important thing about this Plus subscription. So if you take a Plus subscription, you can get access to mock test series and leaderboard where you can interact with me on regular basis. And of course, in small batch sizes, you can learn in more structured manner, right? It will be completely structured. So you can, learn from those courses. For that, you need to download the Unacademy learning app and you need to install it. Then select the plus part, make sure that you have selected your goal as CAT and you press on the get subscription. Yeah, and then you can see various plans. So select your plan, either 12 months or 24 months. That would be quite useful. And apply this code SHAH10. I'm sure all of you will remember this code now. So once again, apply this code and you will get 10% waiver, and you will be able to follow my sessions as well. These are some of our other courses. So if your friends or relatives are looking for any of this preparation, yes, they can learn it free on Unacademy YouTube channel and Unacademy platform. Right. Do not forget about my special classes which I attend on Unacademy platform. So even if you don't have subscription, make a point to download the app and attend my special classes. That will also be sufficiently good. And yes, make sure that you have liked today's video. In general, like our channel and press the bell icon, share it with your friends. If you can post it on Facebook or Instagram, that would be really a good help for us. And yeah, this is our Telegram channel from where you will get plenty of updates, right? So that's it from my end, guys. Once again, I'm Ronak Shah and I'm signing off from this marathon session for today. See you next time for regular sessions. Keep following our daily live sessions. Thank you and adios.